Hello, everyone. Welcome to the Cisco U Theater. Welcome to Cisco Live. Is everyone having a good time? Happy to be here? Thank you for kicking off the Cisco U Theater with me. I see the Apple Vision Pro in the audience. I hope I look better in augmented reality. Excellent. Welcome to Flowin with Wireshark, hacks and tricks to rule the network. I'm your host, Joe Clarke. A little bit more about me later. First, a little bit of housekeeping. You're going to see this slide a lot at Cisco Live. If you haven't been to a Cisco Live before, we have Webex spaces set up for every session you're going to attend, and that includes the Cisco U Theater sessions for the first time. This venue might be a little hard to ask questions, but if you want, you can post your questions in here, and I will answer them as soon as I can get to them. It says we're moderating these only until June 7th. For any of the sessions that I do, I have never deleted or left one of these rooms. People pop in and ask me questions all the time. I'm happy to be able to address any of the questions that you have. We only have 30 minutes today, so a little bit about me. Again, my name's Joe Clarke. I'm a distinguished engineer at Cisco in our Learning and Certifications group. And as of Saturday, I just turned 26. Yeah, 26 at Cisco. I've been at Cisco over half my life, so you can kind of do the math there. I'm an operations guy. I came into Cisco right out of college, right out of the University of Miami. Go Canes. Yeah, go Canes. And I liked software, I liked programmability, I liked automation, and I like keeping my hands dirty. I like, as a network engineer, being able to do stuff all the time. So I help out with various networks, event networks like Cisco Live in Europe, and the IETF. And at one of the IETF networks, I got to know this guy, Clemens, and one of his quotes is, "Packet capture or it didn't happen." We've gotten so complacent sometimes with networking that we'll complain about the network. We'll say, hey, things are slow, or this isn't loading, or I'm seeing weird behavior in trying to do like even a TFTP. And we just forget we have great tools at our fingertips. I started at Cisco in 1998. I remember coming from the University of Miami, we had these Network General sniffer briefcases. Did anyone use one of those? A sniffer was hard to use. It was hard to see what was going on the network. And then this thing came out called Ethereal. This open source kind of, you could do packet capturing yourself. You didn't need to buy some big expensive tool. And vendors started to see the value of that, and they started to pour in investment. People in the industry, in the open source community, they started to add dissectors. They started to add value to this Ethereal tool, and then later they rebranded themselves as Wireshark. And now we have a comprehensive packet capture and analysis tool that at our fingertips that we should never be afraid to break out for anything. Get to know the network, get to know what's going on. Now, how many of you here use Wireshark? Almost everyone's hand goes up. That's good. For those of you who don't, I've got a slide where you can get it. We have this tool at our fingertips, and many of you are probably already fairly comfortable. Maybe it's your go-to for anything, and that's great. But what we're going to do today is go through a few things maybe you're using and maybe you haven't played with, and get you a little bit familiar with things you might not have seen in Wireshark. We're going to look at following streams. That's been around for a while, but it's evolved somewhat. We're going to do decoding as, so applying a different dissector to a protocol or to a set of packets. We'll look at this feature called packet diagrams. I'm in the learning group. This is a nice educational tool. We'll look at a remote capture. Things today are very containerized. We'll look at a way where we can troubleshoot the network interactions, let's say with a container. And finally, we'll look at decrypting traffic, since just about everything on the internet these days is encrypted. Does that sound good? So, these are slides. I'm told I can't be at a Cisco event or even represent Cisco without showing you some slides, but I'm going to attempt the greatest magic trick of all at an event, a live demo. So all of these things I'm going to try and demo live, but before I do that, one more slide. If you're not already using Wireshark, I'll have these slides available for you. You can scan that QR code. It'll take you to wireshark.org, and you can get it. So let's jump in. So the first thing we're going to do is following streams. So there's a few different types of streams we can get. We can get, obviously, TCP. We can get UDP, now TLS, HTTP. So if I start a packet capture on my wired interface, I'm seeing I'm getting quite a lot of packets in here. And I might want to hone in on a specific stream. I'm experiencing a problem with something very specific. So let's say here, I'm seeing an issue with this TLS stream, and I would like to dig into it, and I'd like to filter out all the other noise. I'd like to filter out all the other packets that aren't related to this particular stream. I want to see the SYN. I want to see the SYNAC. I want to see the ACK. I want to look at things like timing in my packet. I can right-click on it, say follow, and I can choose what type of stream I want to follow. I can do, in this case, it's TCP with TLS on top. I can do either of them, but let's say I'm having some TCP issues. I'm having retransmit or whatever issues, and I want to hone in right on that TCP stream. This will show me the data. In this case, it's all encrypted. We'll get to that a little bit later. But if I close this, you can see that I have everything within that stream that Wireshark has seen. Now, if Wireshark had seen the SYN, the SYNAC, I would see that here. But one of the things I now have, not only do I have all of the garbage stripped out, but I also have the timing between the different frames, between the different packets in there. And I can start to do things like performance analysis of this. I can look at specific interframe or interpacket time and gap, and I can see what might be going on. So this is a great thing to do. And as I said, you can do multiple different types of following depending on what the stream is. If this happened to be UDP, we would see UDP here. If this happened to be a SIP call, we would see that here as well. And we can hone in on that specific data on that specific stream. So this is something I've used all the time. Back when I started at Cisco, I was in our network management group supporting Cisco Works. Yeah? Anyone still remember? A few of you. That we still use Telnet for interacting with devices back then. I would follow TCP streams to look at all of the packets that Cisco Works, for example, would send to pull off the configuration from the device. So this is a nice feature. The next thing I want to look at is being able to decode some of the traffic using a different dissector. Many times, Wireshark is pretty smart. It figures out what type of traffic you're looking at, be it HTTP, be it TFTP, TLS. It knows. It can look at the packet. It can do tasting of the bytes in there, and it can figure out, oh, this is the type of packet that I need to be decoding this as. In some cases, it can't figure that out. So I've created a little script here that will send a syslog message, but using a non-standard port. So filter on my non-standard port. I'll start my packet capture, come to my terminal, run my script. And so I see this message here. I see this packet. By the way, note, IPv6, so if you see Eric Vink walking around, I'm doing a demo with IPv6, he'll be happy about that. But you see, it didn't decode this. Wireshark doesn't know that this is syslog, so we don't get the depth, we don't get the detail of the syslog message here. And this could be any other protocol that might be using a non-standard port that Wireshark can't determine, oh, this is HTTP, or this is the particular protocol I'm looking at. Well, it's very easy to do. If you know better, if you know that this particular frame or packet needs to be decoded in a certain way, you can right-click, say decode as, pick the port that it needs to be. In this case, I'm doing the destination port, 5514, and pick the protocol you want to decode as. Syslog in this case. I click on that, and you see it changes. Down here, now it knows, okay, this should be interpreted as a syslog message so that when I dig into this packet, I now see the various syslog fields, the facility, the severity, and then the actual data, the message part of the syslog. Now you may also notice that over here, when my screen resized, it kind of got lost. By default, Wireshark is showing us the bytes. We're looking at the individual bytes of the packet, starting at the beginning, whatever layer 2 header it might have, all the way through into the payload. That's nice. Understanding the bytes, this has actually come in quite handy to be able to see exactly what is, maybe something is using non-reserved fields and they're not setting them to 0, if you're trying to troubleshoot that at the byte level. But something Wireshark added fairly recently in 3.4 was the ability to look at this like you would see it in an RFC, request for comments. People read IETF RFCs? A few hands go up. It can be a great educational tool. I remember, so got maybe a little bit of time for a story here. I remember I was in supporting network management. I mentioned Cisco Works. SNMP was another protocol I supported. I thought I know SNMP. I've been doing this for a few years. I'm still pretty much a kid at this point. I'm probably 24, 25. And I said, this is how the protocol should work. And one of the guys working at Cisco, Keith McClowery, said to me, no, that's wrong. Here, go read this RFC. And of course, it was his name who wrote the RFC. So I now learned that these are a good thing to read. They're very educational. Yes, they can be a little bit dry, a little bit dense, but the reason they're developed that way is to allow interoperability, to make it very clear how these protocols should work, so Cisco and another vendor can actually get together and these protocols meet and do the right thing, even if you're not using all Cisco. One of the things Wireshark now does is take this frame, or this particular pane, and it can turn it into something that's quite educational. So if I want to, for example, change what that looks like, I can go to the layout, and I can say, instead of the packet bytes, I'd like to see the packet diagram. That changes the look to this that you might find, this kind of diagram that you might find in an RFC, that if you're trying to learn how, like TCP, this happens to be a UDP packet, how, like IPv6 is an example, so this is an IPv6 packet. How does the IPv6 header break down in terms of bit width and byte width in those headers? What are the various fields? And then if you click on fields over here, it'll break that down in the detail view of the packet. So this is great. If I was, and again, this guy Clemens, he showed me this. He says, if you're trying to teach someone like how this looks on the wire and how things go together and the various widths of field, and I've needed that sometimes with things like LLDP, to look at the TLVs, to be able to see what should the length of this be. This is a great way to get to know without having to dig up that RFC or dig up that specification for that protocol. How should these headers look? What are those widths? So it's very easy to turn on. I think now in the later versions of Wireshark in the 4.x, this may be the default pane view, and it can be very useful to dig into those protocols. Since we do have some time, any questions so far? I know, again, it might be a little hard. Yeah. I think I understand what you're saying. Can you show again where this is configured? Sure. You also have the slides after this. I'll show you how to get them. But if you go to, this happens to be a Mac, but in general, go to Wireshark Preferences, select the layout, and then you can decide what you want in the various panes. In my case, I like the packet list in the frame pane up top. I like the packet details, the kind of the tree diagram of the frame or packet there. And then pane 3, I can pick what I want to do there. So in this case, I've changed it from packet bytes. So I can say this again, and it returns me to the packet bytes look. Or I can say preferences, layout, packet diagram, OK. And then I get that packet diagram. Good so far? Can I do that again? Sure. Preferences, layout, just stay there. Focus, staying here, aye, aye. How you want to do each of the frames or panes, and you just pick where you want which. So you don't have to do it exactly like this. You can put the packet diagram over there, the details there. You can put details there, list there, however you want to do it. You get to decide your layout. Yeah? Where did I change it to show syslog? In general, there's a lot you can do when you right-click on a packet. You right-click on it or control-click in a Mac, and you get this kind of detail or these options for the specific packet you're looking at. In my case, I came down to decode as. Decode as then lets me decide how I want to decode. I can override how Wireshark is decoding any packet and say, I know better. I want to be able to decode it instead of however you picked it, none in this example. I want to decode as syslog. So I'll go back, actually. I'll go back to none here. For 554, I click none, and then you see over here, now it just shows data, opaque data. After the UDP header, it doesn't know anything more about this packet, so it says here's just the data, the rest of the payload. If I go back and say decode as.
That's based on the port that you put in there, and then it stays in
right, and then it stays in there. It's based on the port that I select, and then as soon as I apply this, it saves. So if I come back, and now I'm using 5514, let's say, as my specific syslog port, every time now I launch Wireshark, it's going to remember that 5514 is syslog, and it will decode the packets in that manner. So that's how you do decode as for any frame that you have. Good so far? Okay, so the next thing I mentioned, that in these days, things are getting quite containerized. So I do want to go back to one slide just to show you this. How many people are using containerized applications? Quite a few hands go up. Well, we are as well. I mentioned I help out with the IETF network. We've created a host that we run a lot of our containers on. We containerize things like Keycloak. We containerize things like NetBox on a particular host. And we've had problems, network-related problems, being able to look at that traffic, being able to look and see what's going on, because everything coming in on the front end, it's all encrypted. What we'd like to be able to look at is how can I look at the traffic between the proxy and the application itself, between the proxy and the container. How can I look at this? Because this is typically unencrypted. So you can obviously run command line tools on your Docker container hosts like TCP dump or Tshark, but there's a neater kind of all-in-one way in Wireshark, and that's called the remote capture. And there's a few types of remote capture. And the one we're going to look at today, is the SSH, because it's the most versatile. With SSH remote capture, you can SSH into like a Linux or FreeBSD. I'm a big FreeBSD guy. You can SSH into that server, have Wireshark run the capture remotely, and then decode it graphically in your Wireshark window as if it were another network interface. So what I've done here is I pointed to our Docker server for the IETF. I'm going to specify my authentication parameters. In this case, I'm just using my username, and I recommend that you use SSH keys. It's better than just throwing passwords around everywhere. So I specify my SSH key, and then the capture parameters. In general, you can leave most of this the default. The one thing you're going to want to do is change the remote interface that you want to capture on. And in my case, I want to capture generally on the loopback, because that's where the containers are bound. The containers are going to be bound on the loopback interface. So let me show you what this would look like without the remote capture. So I'm going to do a local capture, filtering on my IETF server. And they're going to, of course, do that in the background. So let's say I'm having a problem with NetBox. So this is our NetBox entry, or NetBox server for the IETF. If I load this page, and of course I have to log in again. So if I load this page and I come back to Wireshark, whoop, it didn't actually, nope. I want to go back to my interface. The whole, here we go. Start there. Let's see if this works now. There we go. So this doesn't really help me, because if I come here, my follow options, it's TLS, it's encrypted, TLS, TCP. This isn't helping me. I can't dig into why I might be having a problem loading NetBox. This is where the remote capture comes in handy. So this is just loading that VLAN pane, typically on the front end. But if I have access to that server, and now I come over back to my remote capture, I say I want to do the remote capture. Here I'm capturing specifically on that interface. I come back, I load the same window. Now what I'm sniffing on is that loopback. I'm sniffing on that remote host. When I come back to Wireshark, now I'm seeing the unencrypted between the proxy and the containerized application. So if I come up here to the HTTP stream now, I can decode and follow this as an HTTP stream. And I can look at the unencrypted HTTP traffic, and now I can start to troubleshoot a little bit more easily. I was having this problem with a containerized application where there was something trying to connect and do authentication. It kept saying authentication failed, but I'm like, we have the credentials correct. Why is it failing? As soon as I did this remote capture, I saw that it was trying to use basic authentication, and we needed it to use digest authentication. So you can break down, see the HTTP headers, see the payload between the proxy and that containerized application. This isn't just for containers, though. We actually have another case where we, at the IETF, are using remote capture. We've set up a host that we span traffic to, a Linux host that we span traffic to, and we use remote capture to plug our Wiresharks right into that remote host. So this can be very versatile for being able to throw traffic very seamlessly and transparently at your Wireshark without having to jump through a lot of hoops. It's already built into Wireshark. Good so far? Does this work with switches? So there is, I didn't have ready access to a remote device, but you'll notice a different type of remote capture. I said there's a few different types. There's a Cisco remote capture, a Cisco dump, that works with the embedded packet capture feature in our devices. So you can use this particular remote capture with Cisco switches, Cisco routers directly, and pull that in. This was more, the SSH is more, it's a little bit easier to use in terms of being able to find a Linux host. So I had a ready Linux host set up to be able to do this. But yes, you can also do this with the Cisco remote capture as well. So the last thing I want to show, speaking of encrypted traffic, is the ability to decrypt encrypted traffic. I know it sounds magic. It sounds like I just met this guy, Joe, and he's already lying to me. Nope, I'm going to prove that you can do this. It does take a little bit to do it with Wireshark, but these days, the IETF has made it clear that everything has to be encrypted. All new protocols have to be encrypted. Everything is being encrypted. So you saw that last example with the front end. Most of what you're going to be doing on the web, you're going to run into encrypted traffic. How are you able to have your Wireshark decrypt and look at that traffic that's going out on the wire? With certain browsers, Firefox, Chrome are two that supports this. The curl command line utility supports this. You can decrypt that traffic live. So first of all, I'll just show you the nothing up my sleeve thing. I'm going to start a packet capture, filtering on my home server. So I've created a website here at home, this one. Welcome to the Cisco U Theater. Thank you for being here. I will load this page, come back over here, and you can see truly nothing up my sleeve. If I follow this TCP stream, this is what I'm getting. I'm getting the encrypted bytes. Not terribly useful here. But what if I want to decrypt this? I want to look at this particular flow or this particular interaction in a decrypted way. I want to look at the clear text. Wireshark 4.2 has made this exceptionally easy to do. What you do is you go to Tools, so the Tools menu, and you come down here to TLS Keylog Launcher. If you don't have 4.2 and the slides that I have explain what you need to do, you need to set an environment variable and then relaunch your browser. But Wireshark will do that for me. So I specify where I want my keylog data to go. You just specify a file. Then where is the browser I want to use? I'm a Firefox guy, so I'm going to specify the path to Firefox, and then I'm going to have it relaunch the browser. So first, I'll quit my browser, and then I'll click the launch button. Firefox launch, or Wireshark launches Firefox. I'll restore my previous session, so we should go right back to here. Now what I'll do, stop this. I'll put in my filter again. So the exact same interaction I did last time. So there's my filter. I'll start a new packet capture. And I'll do the same thing. I'll do a shift reload on this page. Now when I come back, this is starting to look a little bit better. I'm starting to see some green here, some clear text. If I come here, now I can follow the HTTP stream, and I can see the clear text of my web page right there. Decrypted on the fly based on the key data that Firefox happens to be logging for this session. And now this whole Firefox, any page I go to on the internet, not just my little home server here, any page I go to is going to give me that unencrypted data, because I've launched this with the right environment set, and I can get all of that data that I need. So this is a great way to continue that troubleshooting beyond just the encrypted packets, to get at what is the clear text data, what am I actually needing to troubleshoot for this session. And you can do that. Remember, it's running this way. If you wanted to turn it off, just quit your browser and relaunch it, and the environment will go away. So those were the things I wanted to go over today. We're running almost up on time. I do appreciate you being here. I want to close us out. We went through the decryption. Again, I mentioned you have all access to these slides. This session used to be last year called Cisco U2000. Get out of the way. This year it's called Cisco U2029. The slides are here. So if you missed anything, if you want to get in, everything I demoed, and it worked. The live demo actually worked. Thank you, Cisco U production team over there. The live demo worked, but every one of the slides goes through exactly what I did. You're all network engineers. You're all fantastic. Don't be afraid to use Wireshark. Don't be afraid to explore the features. Read the release notes, see what's new, and tune in next time, next year, where we'll look at even new features in Wireshark. Thank you very much. Enjoy the rest of the show, but before you leave, we have a giveaway under 2 of your chairs, and you don't have to flip them over, though I'm really excited to see if someone does. Under 2 of your chairs, there is a blue raffle ticket. If you happen to have that blue raffle ticket, go see Andy over here, and he'll give you your choice of prizes. Again, thank you very much. Enjoy Cisco Live. Continue to be great network engineers.
Let me reset the timer here. Excuse me. Hi, everybody. I'm Jason Belk, and I'm thrilled to be here at Cisco Live. Couldn't make it last year, and it's just amazing to see everyone here out in force. We got standing room only. I don't deserve that, but this is going to be fun. And so a little bit about myself. I'm the Cisco Learning Certifications team. I'm what's called a technical advocate. So myself, Kareem, and Quinn, and Kyle, our full-time job is basically to engage the community, build content, try to make our community thrive as much as possible through driving engagement on videos, tutorials, blogs, all on Cisco U. We have a YouTube channel as well. So before I even get started, I just wanted to put that out there that my full-time job is to try to make you all succeed in your day jobs. If you're an operations engineer or a manager or something else, I just want to say that I'm here sharing what I've learned, because I'm not a Splunk expert. I'm just going to put that up front. What I'm sharing today is I've been getting into Splunk as we've had the acquisition, and what I want to share is how I got started. And so hopefully that can help you as you're getting started, getting off the ground. Splunk has great documentation, and I'll point to that towards the end. There's a couple key slides that I'll point out that if you want to take a picture or reference later, those are the ones to really focus in on rather than some of the other ones that are more in transition. So a little bit about my background. I worked in Cisco IT and network operations in the campus and branch. And so I know the struggle of what it takes to be a network engineer, being on call. We were supporting 500-600 sites within Cisco IT's network. And something like Splunk is really going to help you understand your data a lot better. So what is Splunk? Splunk was founded in 2003. And the reason they call it Splunk is, if you've ever heard the English word spelunking, that's where the funny word kind of comes from, is diving into the depths of something. And if you ever tried doing show logging all, seeing all the logs blasting at you during an outage, you can definitely feel like you're in a cave, where your terminal is just blown up with commands. And so basically Splunk allows you to be able to sort through, understand what's going on with your data, and then make decisions off of that. And there's tons more to Splunk, but what I'm going to focus in today is more oriented towards the network engineer, because that's the use case that I think of, and I think a lot of people who come to Cisco Live probably have that type of background. So what makes Splunk special when it comes to data? Because you can put data in a file, push Control F, and find the right spot, but the real secret sauce that I want to highlight with this slide is indexing. So when Splunk brings in data, it basically does fancy regular expression parsing as well as other tools to be able to transform that data into a standardized format. Because if you think about even within different Cisco platforms, they have different ways of representing the same data. You might have your timestamps differently, you might have your message formatted differently, and if you're working on more than one platform, which I would be very surprised if anyone only had one platform, even within, say, an iOS platform between releases, you might see changes. Splunk gives you that uniform insight to be able to look in your data, and indexing is that secret sauce where it normalizes all that data and gives you that interface to be able to search, manipulate, and visualize that data. So I have a couple terms up here, like at the heart of Splunk is this data ingestion. You can think of it as a factory where you're feeding in the data, and then out comes these uniform blocks that have their timestamps serialized, and so that way Splunk knows what to do with the data after it's come in. So if you want to really get started with Splunk, I tried both versions. There's a Splunk Cloud version and a Splunk local install version. They have both steps, installations online. I found the local installation just to be a little more intuitive for me, but I'd say, and that's the one I'm going to go through in terms of the process today. I have a Mac, but the installation process is pretty similar for Windows. They have really great documentation. So you're going to need to create an account on their Splunk website, and from there you can download their installer. And what I found kind of cool when I was going through that is they actually have a click, copy, wget down the file. Because normally when you go to a website, you have to click the download button, you have your pop-up and all that nonsense. And so as a network engineer or somebody who's in the terminal, it's nice just to be able to copy and paste that into my terminal and have that file downloaded right for me. After you accept the EULA, which you can do in the terminal as well, you then want to set your admin password. And you can see some screenshots here, basically of what I was doing. Some output, yes, if you want to do the GUI, and then put in your username and password. So after you have Splunk installed, you'd open up a browser and go to your local host address, by default port 8000. And whenever you want to access Splunk, you can either access it on the GUI or on the CLI. So if you're using the CLI, this is the fun path that you're going to be typing in. I'm going to show a trick shortly, adding an alias to hopefully help reduce your carpal tunnel a little bit. And some of the commands that I found helpful just getting started was the help command. So when you type in the help command, I'm not going to try to show that on screen because it's so helpful that it'd be hard for everyone in the back to be able to understand what's going on, because it shows all the different command options, what you can do with the Splunk CLI. So when you're interacting with the application, you can either do it on the web interface, on your local host address, or on your terminal after you have it installed with the appropriate path. That's the default path. Also, if you restart your computer, it's not going to be running. So after I'd installed it and tried to get it going, I was like, oh, is it running? So you can type status. And then, of course, if you want to get started, you can type start. And then you can verify the port as well. So something I found that was helpful when I was getting started with this was adding an alias. So I know, at least for me, when I was in my network engineering role, I didn't know about bash aliases. If you already do, awesome. But something that I've found really helpful is taking commands that are really hard to remember and you might mistype and putting them in your bash profile. They have something similar on Windows, but I'm not going to pretend to know how to do that on Windows, but you can look it up yourself. But the concept's basically the same, where you can take that command that we saw earlier, bend Splunk, with your path, and create a shorthand. So first we create a shorthand, and we're adding this to our bash profile. I'm not going to share my screen because my bash profile has secrets and other things going on. But you can imagine you open up your VS Code editor or any other any other text editor and add what's called an environmental variable in bash. You can say Splunk home is your shorthand way of saying go to applications/Splunk, and then after we have our Splunk home in place, we can reuse that in another alias to then just say go to my Splunk command, and then have that Splunk command be mapped to Splunk command. I just made up that Splunk command. It's not something that is necessarily on the documentation. This is just my tips. And whenever I try to create an alias, I always pick something that's not similar to another command, because if you're typing in commands in your terminal, tab complete is usually your friend. And so I always try to find an alias that, if I'm tab completing, is kind of unique and not going to direct me to some other command. So definitely highly recommend, if you're playing around with Splunk more than just a few minutes, set up an alias for yourself, save yourself some heartache in terms of having to type in that full path and all that other stuff. So after you log in to Splunk for the first time, it'll have some pop-ups asking you, if you want to get started, and have some tutorials, and they're really useful. But really the heart of it is we have search and reporting of different apps. So like the Splunk application has like little mini apps within it that you can install more apps. There's even one for Cisco iOS that you can put in your SNMP credentials and features and have it load in the data. For the example that I'm going through this time, I'm assuming not everyone has access to a network device that has SNMP set up and all that kind of stuff. So I'm going to be giving an example where we have a log file that you can load in manually, because I think everybody can download a file and load it into a system. But if you know how to do the SNMP side of things, that's definitely a great way to play around with it as well. And the first thing we're going to do is add some data inputs, because we need something to look at before we can really search around. So after you click that first step, it's going to say, how do you want to plug it in? Do you want to have it fed in through some type of remote source? In our case, I'm trying to keep it simple, so I'm just going to load in a file directory. I got this source data that I'm going to be demonstrating through here through a publicly accessible DevNet sandbox. So if you're aware, DevNet has online sandboxes. Some of them are reservable, some of them are always on. And the always on sandbox, they have one for iOS XE. So I don't have a production environment to grab logs from, so I figured, well, if people are just always jumping onto this thing, there's got to be some interesting logs on there, at least to kind of demonstrate and walk through. So I went on to the always on sandbox, went into their log file, downloaded it, put it into a GitHub repo that I'll share on the Webex Teams for this session, and that's what we're going to be adding in here today. One thing I'll say is that on the pop-up, it asks you kind of the full path for what you're going to be working with. And if you're using VS Code, which I recommend, if you don't already have a preference, you can actually right-click on a file. So if you download the file, you have that file up on your terminal. You can right-click and you can click Copy Path, and that's going to give you the full path to the file, rather than having to type it out or do some other nonsense. So in order to add our test data, you can see my path here. We're still in the files and directory. We're moving along in our process of adding in information. You can see I copy and paste it in. You could browse, of course, and then you can either continuously monitor or index once. For what I'm working with a static file, it's not going to make a difference. But if you had a file that, say, was being tail left into a file and was constantly being updated, I think continuously monitoring is kind of a neat feature to be able to have, even just for files. And after the file's in, so you can see at the top here, we're going through the flow. We selected our source, we added our file, we had our path, so we didn't have to type out stuff. And now we have setting the source type. And this is where the indexing comes in handy. So if you look on the left-hand side, by default, it just says it's going to be a text file, and I'll do the best I can to try to figure out what's going on. But you can also select from some handy-dandy different Cisco types. So we have Cisco ASA, Cisco iOS, and a couple other Cisco logs, different things going on. So since I was working on the Cisco iOS device, I chose that from my select on the dropdown. You can see some of the log message here. It's already starting to process the data. And this is what it comes to when talking about indexing, is I'm telling when you're defining your data type, that gives the application the reference to say, okay, I know what type of data to work with. And for example, when I had a file in here that had, basically I did show logging to look at the output, and it had other additional commands, I noticed it wasn't parsing it correctly. So just be aware of, if you're going to be selecting a particular type, make sure that that log file is just the log file. You don't have like the show logging or the, the prompt from when you're interacting with your network device in there as well. So by default, it gives the host field value of whatever device you're working on. So I gave my laptop name in there, and this is kind of important to make sure that you're flagging the device when you're setting it up, because if you're adding multiple devices, you want to have their names be unique. So that's the name of the DNS resolution for the sandbox we're working at. So I actually updated that field. That's not a default field. And then it's going to be able to have that host as we're doing our searches later on with that particular name. So now that we've added in our data, we can start searching. So they have lots of great examples and tutorials you can link to. But for here, now that we've done our data in, we're moving into the Splunk GUI. So at the top here, this is really the heart and soul of Splunk, is being able to use this search bar. And so up here, it's kind of small for in the back, but on the left, we have the really long path from my home directory all the way down to where that log file is. We have devnet sandbox, basically the host name right here, saying the host is equal to the host name, and then our source type is Cisco iOS. So that information, I pretty much copied and pasted in from the path, the name, and then we already knew the source type because I was going through one of the examples. And from there, we have all of our data just on the bottom, ready for us to interact with. And on the left-hand side, I don't know if you saw, but we have these selected fields. So as soon as it's parsed in that data, it's starting to say, these are the keywords that you're probably going to want to start looking at. And if you hit on, by default, it's by smart mode, but you can actually have different ways of displaying the amount of data that it's going to be giving you from that parsing. So you have two different directions. You have fast mode and verbose mode. I think if you're working with some really big file, you might want to start with fast mode until you kind of get your bearings. But since I was just working with a really simple sandbox, there wasn't even any OSPF or any type of routing going on, I just started with verbose mode just to kind of see what all of my options are. And you can see some of these keywords popping up in terms of severity, date, and these are all standardized fields that are not just from Cisco iOS, but you could then go across different platforms. So I have some different search term tips. That search terms, when you have it on the top of that search bar, are not case sensitive, so don't worry about that. Don't be upset, worrying about your caps lock on or not. And of course, it has typical wildcard. If you do a star, just like in Linux, you could say if something failing, and then anything after that, I don't care about what's going on. Typical Boolean values as well, if you're working with order of operation from your middle school days or whenever you learn that. You can have your different search terms grouped in parentheses and using Boolean values like I want to search for this and not something else. And if you're searching for something that is one of the values that is already in the search syntax for Splunk, say a quotations mark, because if you saw in our Splunk search terminal, we were using quotation marks to denote the values of what we were searching for. You want to use an escape character such as the backslash if you're actually searching for a quote, because it's kind of a meta thing. How do you want to search for a quote? Well, you use an escape character. So this is one of the key slides that I was talking about earlier that really helped me understand. That's why I color-coded and made it kind of fun, is we have our source, our host, and our source type. That's not going to change at all. But as you're getting used to what's going on, you have commands, functions, arguments, and clauses. And then I'm going to use these same colors throughout my other slides to be consistent. And I'm not expecting you to memorize them. Like, I'm still getting used to Splunk myself, so I'm just learning it myself. So we have commands, functions, arguments, and clauses. You can see we have our stats command. So after all that data that we saw, we'll be scrolling down the screen, we can then issue a pipe command and say, let's take that data and feed it into a stats command, which will then basically count the number of actions that we have. So actions, you can see there, it's orange, is an argument for our function, which is counting. So we're going to be counting basically the number of something happening. So this is what it would look like in the actual command. I try to get a in-progress search quick snapshot on our screen, so we have our source type iOS, and then even as you're typing, it has autocomplete for your different options. And you can see what was counted down here. You can select based on those different fields on the left-hand side, what do you want to count? And so in my case, I wanted to count basically authentication failures or successes. And so you can see the little tiny font down here. I tried to do the best I could, but there's a lot of information to show. We have failures and successes on the left-hand side, and a count of 226 and 227. There's kind of an equal number of successes and failures for this particular device. And so that gives me a bird's eye view. I mean, for a sandbox, it's not a big deal, but it could be significant if you have like an extranet gateway or something that is public facing and is somebody trying to attack my device, being able to understand if people are doing too many attempts and things like that. And then now that we have that data, so we still have our search bar. Before we were showing you like the statistics tab, the events tab, which was all of that terminal output, and you can start visualizing. I mean, this is a super simple example, but that's kind of how you should learn and get started. We have our failures, those 226, 227s, and our successes. So you can start taking your data and just visualizing at the click of a button. And I think if anybody is in a network operations role that has any type of management, they love seeing charts. So this is like catnip for managers. So I think Splunk is great for that, where you can build charts and show them, hey, this is what we're looking at in terms of security vulnerabilities or operational uptime or whatever you have on your devices. As long as you can build the right search terms and figure out what's going on in your devices, you can start visualizing those reports. So before we showed pipe stats, but now I'm showing you another command. So we had our long command and then ... pipe. Now we're showing time chart. We're showing over time how many authentications have happened, how many times have people logging into this device. So just by using the same exact command and then now having the same exact search, now with a new command, we're saying we want to basically count this over time, and now I'm using a visualization to say these are all the authentications that happened for this public sandbox. And you can even string together your pipe command. So for this one, we can actually add another search. So we're searching within our box, but what if we wanted to narrow down that search? So we have our search, our first pipe, and then I say, I want to focus on just the failures and successes. So I can say search just failures or successes, going back to what we were talking about, Boolean. And then now we add another pipe, so we filter down from our big data down just to failures and successes, because there might be other situations it's talking about. And then we take that and add time charts. So you can see this is a lot more granular because we're just focused on one particular use case. And for this one, I just wanted to give a bird's eye view in terms of the different charts you can do. So like, say, they also have geotagging data for different types of search results. So if you wanted to visualize it on a map or have different line charts or pie charts, all the different options they have on there, it gives you some of the different visualizations. And what good is a report if you can't share it with anybody? And so like, in order to share it, you go onto the top right of our search screen. There's a save as, so you can save it as a report or add it to a dashboard. I'll show you a dashboard in a minute, but just show you that this is what it would look like. You kind of give a title, a description, and this time range picker is basically allows you to give the option if someone else wanted to see that same dashboard, do you want to give them the option to drill down to a specific time or just keep that time static? So after you have that report, you can then add it to a dashboard. And so that dashboard will be dynamic based on the data, if the data is dynamic. And you can see there, if we're adding to a new dashboard, it asks for typical stuff, like you need a title, description, optional. Who do you want it to see by default? Nobody can see it, so you probably want to be able to share it with somebody. And they have two different dashboard types. One's called Classic Dashboards, the other one's called Dashboard Studio. Classic Dashboards is more for the OCD types who like having every pixel in place. And the Dashboard Studio and allows you basically just kind of drag and drop stuff and it kind of clicks into place. So I stuck with the easy one in terms of Dashboard Studio and using Grid. And now that we have an existing dashboard, we can then share our dashboard with other people. So you can either download as a PDF, PNG, and be able to share that with other people. And so I actually took 2 different visualizations and then added them to the same dashboard. And then you can filter over different time periods as well. So my final call to action, this is the other kind of major slide, that you should really check out the Splunk documentation. I have all the links down here on the bottom. On the left, we have their installation docs. I found them useful in terms of step-by-step guide, but they don't have a broader narrative. Like, they do a great job making sure that everything's in place, but it's very formulaic. If you're like me and you kind of want someone explaining it to you like I'm doing right now, I'd highly recommend checking out their training. So they have free training online. You can log in, set up. It took me like maybe an afternoon to kind of go through all the videos. You can do it at faster speed, of course. And as well, they have a whole YouTube channel called Splunk How To that I highly recommend. They have tons of 3 to 5 minute videos as well as longer form videos as well, covering all kinds of different Splunk use cases. And this is basically my call to action. It's like, if I've kind of whetted your appetite in terms of what you can do with Splunk, follow up on there for their documentation, but also for us on Cisco U. We are learning certifications, and as time goes on, we'll have more and more Splunk stuff on our side as well. We have tons of tutorials, and they're all freely available to everyone. So from topics of security, I've written some on Yang data modeling, network automation. We have some on, as well on networking for CCNA, as well as our new cloud certifications. We have the enterprise network cloud connectivity. So definitely check out our Cisco U free tutorials. We also have a YouTube channel as well for Cisco U. And kind of our final little gotcha, we have 2 tickets, blue tickets under one of those seats. You don't have to flip your seats up. There should be, you can check under your seat, if you're seated in this main seating area, there's 2 free redeemable tickets for, I can't remember. And then with that, I'll give everybody 5 minutes back to get some lunch. Well, you got one? Great. You can come up here and we'll figure it out over here. Thank you, everybody.
Hello, everyone. Good afternoon. Welcome to Cisco Live, and welcome to the short 30-minute talk called Cisco Express Forwarding Deconstructed. My name's Peter. I am associated with a training team in Cisco, but I used to be a tech engineer in the past, and I just love things about routing, and I also love sharing things that I know and learning from you from the audience. So I'm taking this as an opportunity to share something I know and also hear your opinions on it. I've called this session Removing the Mystery from the Common Sense because Cisco Express Forwarding is marketed as something very, very sophisticated, and it is, but once you understand it, you'll start thinking, why didn't we do this the whole time along from the first time? So it is really an easy thing once you get to understand it, but I know that out in the wild, there are many hearsays about what it is. Is it hardware-based? Is it software-based? Is it on switches? Is it on routers? Does it do switching? Does it do routing? I'd like to clarify these things so that we can get this done. Just a short reminder, in your Cisco Events app, you can join the Webex space discussion for this room. And if there are any questions after this is ended, you're more than welcome to share your questions. Though formally we say that the space is only moderated till June 7th, I'll be along for much longer, so feel free just to chime in and ask. This being said, let's take a sample topology here, 3 routers speaking EIGRP, by the way, between each other. I like EIGRP, okay? And we have a bunch of routes advertised from R2. They all will be starting with 172.16, something, something. And we have a bunch of routes advertised from R3. And they will all be starting with 192, 168, and then something, something. So this is going to be the simple topology. And we will be looking at routing between these networks. So this goes toward the way that Cisco Express Forwarding really covers the routing part of forwarding. Now, everything that I will be discussing will be from the viewpoint of router R1. Of course, all routers here will do the same thing, but since R1 is in the middle, and there's a bunch of networks behind its neighbors, that's where things start getting interesting. So I'll be looking at R1. And on R1, if I pull out the routing table and ask it, what remote networks does it know? I'm just going to ask about IP route EIGRP. I'm going to see a couple of networks from behind R2. They are the yellow ones. And I will see a couple of networks from behind R3. Those are the green ones. Okay? And so now, if we involved routing between these networks, everybody knows the textbooks, how we say it, and I even remind you of that. We will be searching for the best match, the longest prefix match in this routing table, and the routing lookup will give us the outgoing interface and the next hop address to forward the packets to. And so that we know how to frame the packets toward the next hop, we also need an ARP table if this is an Ethernet. And let's assume that it is. So R1 will also have its ARP table mapping the IP addresses of its immediate neighbors to their MAC addresses. So far, so good. Now, when you come to the classical textbooks that describe how the IP routing works, what would those textbooks say? And this is a quick refresher so that we are all on the same page. The classic textbooks would say, so you've got the routing table, the one that I just showed you. Even though it's not printed like that, imagine that it's sorted by network masks in the descending order. It's like you take all networks with the prefix length /32, so 255, 255, 255, 255, and put them right at the top of the table, all of them. Their order doesn't matter, but all the /32 networks will be on the top. Right after them, you will put all /31s, and then /30s, and then /29s, and so on. And so the default route, which is /0, will be completely at the bottom of the table, the very last entry. If you did this for IPv6, the same thing, just we have longer prefixes. Now, the textbooks say, when you get a packet that you need to route, you will take the destination IP address from the packet. Row by row in the routing table, you will take the net mask from the row in the routing table, do a binary AND between the destination IP of the packet and the net mask in this row. You get a network address with a certain given prefix length. And you compare that address to the network address in the row of the routing table. If found a match, you stop here. And because the routing table was sorted by net masks, what you just found is the longest prefix match. You stop here, and you have found a matching route. You have the outgoing interface, and you have the next hop. If you didn't find a match, you try the next row and next one until you first hit a match. This is how it's explained, and certainly it would work, but it's a little slow and it's a little naive. Let's just pull through and see what happens now. If we identify the outgoing routing entry in the routing table, the routing table entry will tell us, hopefully, the outgoing interface and the next hop IP address. It might be, and this is specifically the case for static routes and BGP learned routes, that you will see the next hop but not an associated outgoing interface. In that case, you need to take that next hop itself and do another lookup in the routing table all over from scratch to find out where is the outgoing interface toward that next hop. We call this the recursive lookup. In theory, you may hit just another route that again has just a next hop IP address. So you need to look up the next hop IP address again. In theory, there is no limit to this recursion, although normally it's just 1 to 2 stages and no more. Once this process has ended, however, we can hope, and this was the routing table lookup, we can hope to have an outgoing interface and an IP address of the next hop on that outgoing interface. How do we use this? We use this to now find the layer 2 address of that next hop on that interface so that we can create a frame for it and send the packet through it. If it's an Ethernet, it will be ARP table. If it was an old frame relay, we would be looking into Delcy tables, and so on and so forth. By far, ARP is the most typical today. Note that the whole process has 2 stages, really. The first stage was you spending time in the routing table, just trying to find the proper matching entry. Might have taken quite some time. And once you found the matching entry and the outgoing interface and the next hop, then you went into the L3 to L2 table that maps the next hop IP to its layer 2 address. And you use that information to construct a completely new frame for the packet and send it on the way. So there are 2 stages, route lookup and what we call a frame rewrite. Because from outside, it really looks like that. A frame comes in with a packet. The packet doesn't change really when you route it, but the frame changes because you rewrite it. At best, you change MAC addresses. But if you go out an interface that contains a completely different encapsulation, maybe from Ethernet to a serial interface, you change the frame format completely too. So this is what I'm talking about here. If there was a packet going from behind R2 to somewhere behind R3, so from top to bottom, what R1 would see on ingress when a packet comes in, this is a very short, simplified frame. I omitted a bunch of fields here. You will see the destination MAC being the R1 itself, and the sender would be R2 because the packet came from behind R2. You do this all magic in the routing table, and you do all lookups in the ARP table, and you produce a new frame with changed MAC addresses, maybe completely changed frame format, but the IP packet really didn't change, did it? It didn't, right? Sure, we decremented TTL, recomputed checksum, but that's a sort of a given. Fine. So we do this frame rewrite here, and it takes a certain time. I want you to think of a few observations about the whole process we just did here. The first observation is that if the routing table is, well, truly a table, a linear structure, first entry, second, third, and so on till the last one, then performing lookups in it will become progressively slower as your routing table grows larger. If you have 1 million routes, and the packet you just got needs to use the last one, the last entry, the default route, you need to go through the 900,999 till you hit the last one, right? And if you have another one, it will get even longer. So routing table isn't really ideal as a structure to perform quick lookups. Second thing, the routing table contains a bunch of information that was necessary to construct it, to populate it, but not for routing lookups. Where in the whole process were we looking at administrative distances, or costs, or metrics, or tags, or timers, or what have you? Nowhere. That information is used to populate the contents of the routing table, but once it's populated, this information is not useful to make lookups. And so it's a little of just a ballast information there. We don't need it for routing lookups. This is a very important thing. A router may know about hundreds of thousands of routes, but it will only have a handful of neighbors, right? So those destinations and their reachability somehow spreads among those few neighbors that you as a router have. And this is a consequence, really. If you have a bunch of destinations reachable through the same neighbor, then the frame rewrite for all those destinations, hundreds, thousands more, behind the same neighbor will use the very same frame rewrite because you're addressing that neighbor by its single MAC address that it has. And in the end of this whole process, the purpose of routing, knowing all this, can be rethought as trying to perform a very fast lookup in the routing table so that we obtain a frame rewrite information and outgoing interface so that we can slap the frame header on the packet, off it goes. And this is where the improvements in the Cisco Express forwarding will be coming in. Cisco Express forwarding, or CEF in short, is currently the primary method of how Cisco iOS and iOS XE-based devices, both routers and switches, do these operations for routing and frame rewrite and sending packets out. It's an L3 thing, right? For basic L2 switching, we don't use CEF. But for L3 routing, the multi-layer switching, as we used to call it in the past, this is where CEF comes in. It's the culmination of multiple approaches in the past. Maybe you remember process switching, a fast switching, optimum switching, silicon switching, and now we have this one. This is the last stage where we got to, and it's sort of perfect for what we do. And technologically inside, CEF consists of two components that make this improvement possible. The one component is called the forwarding information base, or FIB. And the second component is called the adjacency table. What's what? Now, as I mentioned already, the main routing table, as we described it just before, isn't really ideal because all those drawbacks that I've mentioned. It's recursive, contains a lot of unnecessary information, it's linear, and so on and so forth. So what we do with CEF is take the RIB that still stays in the router, but process the contents, I like to call it, we distill it into a rarefied form that simply removes the recursion when we process the information, removes the unnecessary information such as costs and administrative distances, and is organized for very fast lookups. This is what we call the forwarding information base. And it's populated based on the information in the RIB. Now, the FIB itself in the device can be either software-based or hardware-based. If it's based on software, it's usually done using data structures we call prefix trees or tries. There are also other methods, but the tries are very illustrative. If it's implemented in hardware, this FIB, then it's in the switch ASICs, the application-specific integrated circuits, and the part of them that does this is called the TCAM, ternary content addressable memory. A quick overview of both. The try, as mentioned, is a tree, and here the idea is that I'm not going to compare the IP address or the destination byte by byte or as a whole 32 or 128 if IPv6 bit number with some masking and repeated computations. No, remember, the IP address is a sequence of 32 or 128 bits. I can look at their value one by one, bit by bit, not byte by byte, but bit by bit. And I can store that information about those prefixes in a tree that has nodes, and we used to say that it has right child and left child, but if you code it in software, it can be just first entry, second entry of the node, or whatever you call it. But we will have a convention. If the bit I'm looking at is known and is of value 1, then I will be creating a right child in the tree. If the bit I'm looking at is known and has a value of 0 in the IP address, I'll be creating a left child to the node. This might be an example of a tree that contains 1, 2, 3, 4 known prefixes. They are marked with red circles here, and you just always traverse the whole way you can to get to the prefix, and always look at the red node. The red node is one that we call the terminal node, saying this is a valid prefix. So what do we have here? This is an extremely shortened one. It just contains 3 bits, not 32. Just for an illustration. There would be a prefix known here called 111. There would be a prefix 010. There would be prefix 01, because this is also a terminal node, and I don't need to go down. So every red circle is interesting to me. And finally, just 0. Sorry, it's just 1. These would be the prefixes in the tree. And now imagine that I'm performing lookups in this tree. How is this faster? Let's say I'm looking up address 111. I will start from the root, and bit by bit, I will try to go to the child that is supposed to match the value of the bit in the address. I will remember if I saw any red circle, because that means that's a valid prefix. And I'll try to go as down, as deep as I can. And once I cannot go further, then I'll simply use the latest found red circle, because that's the longest prefix. So let's see. The address is 111, simply, in bits. So I start from the root. That's the 1. Is there a child 1 for the first bit of the address? Yes, there is. Fine. And this would be one of the first valid prefixes, but let's try further. The second bit in the address was also 1. Is there a child 1? Yes, there is. So I can go further. Third bit, 1 of the address. Do I see it here? Can I go there? Yes, there is such a child here. So in this case, searching for the longest prefix of an address 111, I found a prefix that matches it completely. This would be like /32 match for host. Notice that for 3-bit addresses, I made at most 3 comparisons. No matter how many prefixes I have here, at most 3, because I'm comparing bit by bit. With 32 bits, I will compare at most 32 times. Not a million of times for a million entries in the routing table. I do have a bunch of other examples of lookups here, but let's skip them, and let's move forward to the other interesting part in Ceph. Just remember, this is the part where we perform the routing lookups by searching for the longest prefix. Here we go. If we're talking about the TCAMs in hardware switches, because the previous implementation was software-based, the TCAM switches, or the hardware switches with TCAMs use the TCAM as a memory to organize these prefixes. And when we say TCAM, it's a memory that works from end to start in a reverse mode sort of way. A normal memory works by you giving the memory an address, and the memory returns whatever is stored at that address, right? This TCAM memory works in a reverse direction. You give the memory a value, a content that you're searching for, and the memory will tell you if it has it at any address. If not, it's also going to tell you. So what we're going to do is store the prefixes into this TCAM at selected addresses. And the TCAM has the T bit, or the word ternary here, because its specialty is that it can also declare some bits as uninteresting when matching them. So this is ideal for network prefixes, because every network prefix has the network part, which we're interested in, and the host part, which we're not interested in, and that would be the wildcard mask in the TCAM. And so here, on the hardware switches, the TCAM would hold all the prefixes from your routing table. You would give it the IP address, and it would, in parallel, search through complete its contents, and very quickly give you the address where the matching patterns are stored. And you would then select the one with the best, the longest prefix match. And since this is done in hardware, optimized, this is blazing fast, blazing fast. Why did we do all this? because we wanted to find an entry that points to the frame rewrite. The frame rewrite, however, is not stored in the fib itself. Rather, there is a separate table, the second one inside, which is called the adjacency table. And the adjacency table is the one that contains complete prepared frames for my neighbors so that I can just directly use them, slap them on the packet, and let it fly. Is anybody here who was working with SQL databases in the past? Okay, you know that sometimes for fast lookups, they were creating indices or indexes over certain columns. Well, people, a fib is a tree-based index over the adjacency table, with key being the longest prefix of your destination IP. This is what we do. And how is this useful? Let me go to a short demo here. And what I have here is just the topology that I had in my first slide. And let's see how this all combines together. So this is my routing table, and you've already seen it, but I'm just pulling it out so that we can see it. As I have been playing with two parallel connections between routers 2 and 3, I have two identical paths to all those 190 to 168 routes, but please don't get confused by that. So there are some routes here from behind router 2, which is the 10012, and some routes from behind R3, which is 10022 and 222 as well. I also did a nasty sequence of static routes here. Notice this. This is a manually created, deep, recursive set of static routes, where I'm saying, yes, there is a network 1, but to reach it, you need to go something through 2222. How do I get to 2222? Well, there is a network 2/whatever, but in order to reach it, you need to go through 3, and to 3 through 4, and 4 is finally just pointing out an interface. This is recursion, because none of these routes here, until the last one, will tell you the outgoing interface. You need to search for it. When Ceph takes all this information and compiles it into fib, it removes this recursion. Notice that this eventually points out interface E01. So if I want to see the data in the fib, I just pull out show IP Ceph command. And notice all these entries here, network 1, network 2, network 3, network 4, immediately point out the last searchable next hop, which was all 4s, and immediately it points out the interface, is Ethernet 01. You remember in CCNA 1 course, we used to say, if you're doing a static route, you better specify both the outgoing interface and the next hop to remove the recursion. With Ceph, you don't care. It's not necessary. You don't need to. And also, pardon me, there are those networks already, the other networks that we had here, for example, these ones. Although, looking here, you don't see much of a difference compared to the routing table, because the routing table with IGP always tells you the next hop and the outgoing interface immediately. But those static routes, they show that the recursion is being removed. Now, what is very important here is no timers, no costs, no administrative distances, just the necessary information. Next hop, outgoing interface. And now, let's take the next hop, 10022. Here, although I'm not going through the low-level pointers, we internally point to a proper adjacency table entry. If you want to see the adjacency table entries here, this is the output, show adjacency. And now I'm only interested in the next hop, 10022, so I'm going to pull out that information. Well, the information here is that it points out the Ethernet 00, which is nice and not really useful. But worry not, this command is just hiding the most interesting data before your eyes. Just a detail. And notice this looks like gibberish. AABBCC something. That's not a gibberish at all. Look here. This is my ARB entry for that very next hop. AABBCC000310. AABBCC000310. That's the destination MAC. And that's how Ethernet frame starts, with the destination MAC. And what's the next 6 bytes there? Well, let me show you my own MAC address on R1. AABBCC000200. Here we are. AABBCC000200. Source MAC. This really looks like an Ethernet header. Destination MAC, source MAC. Anybody who can tell me what this 0800 is? Ether type for IPv4 precisely. This is nothing else than already prepared, ready to use Ethernet header. You just point to it, stick it on the packet, let it go. Wonderful. Now, if I pulled the information about that second next hop that I was showing here, notice I have a sub-interface here. So that you can trust me that it's a sub-interface. What was it once again? 0011. It's using VLAN ID number 11. So if I pull out the information about the next hop across this interface, show adjacency 10.0.22.2, detail, notice that the whole thing is a tad larger. And what do we have here? I'm not going to read the MAC addresses for you anymore. But what is this here? 4 bytes, starting with 8100. That's a VLAN tag. The 8100, it's an ether type for a VLAN tag. So 2 bytes, 8100. Then you remember 3 bits for priority, 1 bit for discard eligibility indicator, and what was it? 10 bits? No, 12 bits for VLAN ID. 0B is, pardon my French, 11. So, again, it's a fully prepared frame. It's there to be used. And this is what the adjacency table truly does. By the way, and I'm leaving this as a home exercise, try configuring a GRE tunnel. And then try to see what Ceph and adjacency table will construct for you in the adjacency table for the GRE tunnel. You might see some IP packet there, IP packet header there. So, to conclude, when you think about this, yeah, it's sophisticated because somebody took the time to think about the process. But now that you think about it, wow, so simple. Optimized version of the data that we use for routing and prepared frame headers for packets as we send them across the different next hops that we can reach. And finally, this might be a little surprising. Ceph on routers is typically just in software. But if you use on multi-layer switches, catalysts, then in fact, FIB exists both in software and in hardware. In hardware, it's for the normal traffic. And in software, it's there if you need to handle packets that cannot be handled in hardware because of some limitations, say, need fragment packets, but you want to have the same behavior. So you will have both of them. All right, with this, I thank you very, very much and wish you a very nice rest of the day. Thank you.
Hello, everyone. Can everyone in the back hear me all right? Yes? Okay. Well, how's everyone feeling today? Good? Tired? Already? It's the first day. Is anyone excited? Please say yes. Yes. Thank you. Thank you. All right, so welcome to Cisco Live, and especially welcome to Cisco U Theater Sessions. My name is Akhila. I am a software engineer in learning and certifications at Cisco. So, and I'm a little nervous because my computer was giving me issues like 10 minutes before this presentation. So I had to restart everything and resource everything back. So I'm a little nervous. So recently, I've had the chance to visit one of our data centers in Texas because we were moving some of our lab equipment there. And I went to help with some inventory stuff. And I've never been to a data center before. It was my first time. And coming from a non-networking background, I'm not a network engineer, and coming from this not networking background and going into the data center for the first time and standing between, the big racks and the servers and the switches and all the cables and the noise, not to forget, I was kind of struck by how complex our network can be, and not just our network, right? It can be any network, how complex a network in general can be. And then I realized how important it is to accurately document this stuff that you see in a data center. And then I realized it's not just the things that you see with your eyes. It's not just the physical things that need to be documented. It's also the things that we don't see, like virtual machines or IP addresses or VLANs or tenants. All of this, it's kind of like an ecosystem, right, that needs to be meticulously documented and be kept up to date, because it can give you problems if you don't do that later, right? And then, when I was there in the data center and helping out with the inventory, right, I used to just use spreadsheets. I just dump all the data in the spreadsheets. And it's fine to do that in spreadsheets. It's the go-to method. But it's what you do after you dump the stuff in the spreadsheets. It's the processing of it, and it's the maintaining of the spreadsheet. So maintaining all of this network information in spreadsheets in the long run can get to you. It can become a hassle, right? Because, for example, let's say your network keeps on scaling, and you keep on adding more and more devices to it. Right? Maintaining all of this in spreadsheets, it can become a hassle, right? Especially when you also have to share this information with your teammates. You don't want everybody having their own version of their spreadsheet. You don't know what the recent one, what the most accurate one is. So this is where NetBox can come in. All of this information on your network, all of these things that I mentioned that needs to be documented, NetBox provides like a consolidated platform for everything on your network. Now, having all of this data in your spreadsheets is one part of it. Now, how do we put this data into NetBox? And that is going to be our topic of discussion for today. We are going to learn how to automate network operations in NetBox with Python. Let's get started. This is the Webex chat for this session. I'm sure all the sessions that you've attended so far, you've seen this slide. You can join it through your Cisco Live app, and if you have any questions during the session or after the session, I know it can become a little bit difficult to shoot out your questions here in the crowd, but if you have any questions whenever, I personally am never going to leave this chat until I work for Cisco. So if you have any questions whenever, just shoot your questions in this chat, and I will be happy to answer them. So here's our agenda for today. We will talk about NetBox and what's in it, and we will talk about automation with Python, and then we'll go into our live demos. We have 2 demos in line today, and then I will answer any questions you guys have. So let's go to the next slide. So what is in this magic box called NetBox? We have a box. It's called NetBox, and what's in it? Has anyone ever used NetBox before? That's a lot. That's really good. I like seeing that. So NetBox, as I mentioned, it's a centralized platform for your network infrastructure. It can do your IP address management, your data center infrastructure management, your cabling management, and your rack layouts. It's also called as a single source of truth. Now, what does it mean to be a single source of truth? It means that whenever somebody has a question about the network, whenever somebody wants to know anything about the network, this should be your go-to place for everybody on your team. And this is why it's so important to keep NetBox up to date. And as I mentioned, your network can scale, it can grow, right? And so NetBox is also scalable for that reason. As you keep on adding more and more stuff to your network, as your network keeps getting larger and bigger, you need a database that can handle multiple users and multiple requests at the same time. Because in spreadsheets, it can slow down a bit if you keep on adding more and more rows. So NetBox having a Postgres database, it can do exactly that for you. Okay, one of the important features of NetBox, and something that we're going to see today live, is that it leverages automation. It provides RESTful APIs that enables automation through either scripting or through integration with other tools. And we have 2 demos that we're going to see. Today we're going to use Python as our tool for automation. And all of this boils down to improving collaboration or enhancing collaboration as a team, because as everybody should go to this single source of truth to look for anything on your network. And one important thing that I wanted to mention, because I'm on Reddit a lot, I'm on the app Reddit a lot, and I'm in the NetBox group for Reddit, and I see people posting questions like, how can NetBox monitor your network? How can it configure your devices? Now, NetBox is a whole lot of things. It can do so much, but one thing it is not is it's not a monitoring tool, and it does not configure your devices for you. It is a place of documentation to keep an accurate view of your infrastructure. Now, having said that, it doesn't actually update the devices by itself. There's so many network automation tools out there that you can use to integrate with NetBox, like Ansible or Terraform, to do your configuration management or your resource management. Or like today, we're going to use Python to automate our network tasks. And today, as I said, our focus is going to be Python and just Python. So we are going to learn and see how we can use Python to automate our tasks in NetBox. And for that, we are going to use a library called PyNetBox. And as the name suggests, it's Python and NetBox combined. So let's not waste any time, and let's dive into our demos. I'm going to switch back. Oh, my bad. One more slide before going to our demos. Our first demo today, we are importing new devices into NetBox. We have 10 new routers that just came in, and we have to import new routers and their details that are listed in the spreadsheet into NetBox. Look at the spreadsheet, a little bit about the spreadsheet, the attributes of the devices. We have routers, 10 routers, and they have device types, which is ISR 4321. It has a device role, it's the router, the site that it's located in, the rack, the position on the rack unit of it, if it's facing front or rear, all of these are going to be facing front. The status of it, they're going to be in inventory, and the serial numbers of it. So these are just the attributes of all these routers that we have that are listed in a spreadsheet. Now, before I go into the Python script, I just wanted to show you the NetBox UI. So let me go into the NetBox UI. So this is the homepage of NetBox, and on the homepage you could see that it has a summary of statistics, like under organization it has sites. Right now I have 2 sites. This is a testnet box, by the way. And I have tenants listed, I have inventory. If you look at the left side, the leftmost pane of NetBox is divided up into sections. Under organization, it's divided up into sites, racks, tenants, and under sites you have site groups, regions, and under racks you have racks, your elevations, tenants, tenant groups. Under devices, it's divided up into devices, device types, and device components. Under devices, there's devices, device roles, platforms, which is your version. You have your device types, and you have your components, your interfaces, front ports, rear ports, and whatnot. So as an example, let me go into one of the devices and just show you how it looks like in NetBox. So here's a device, and you see how it's very convenient to have NetBox, because if you click on a device, you have all of its attributes, all of its component in one place. You have where it's located, the region where it's located, the device type of it, the status that's in, the IP of it. And if you click on interfaces, you have its interfaces. You have all of its interfaces in one place, and you have its cable connections as well. So this is the beauty of having everything in one place. Now, if you remember for our demo number 1, I don't know if you remember, but I remember, but we were going to import all of that information in Rack 25Y. So now let's go to racks and just see what's in Rack 25Y. So I don't have much in Rack 25Y. I have 5 devices, which are not the routers that we're importing. It's empty now. Now let's go back into our script and run it and see how it works and how to import this stuff into NetBox. Can everybody see it in the back? Should I zoom it up a little bit? Or is it good? It's good? All right. Or I'm just going to zoom it up just for the heck of it. All right, first thing we're going to do is we are going to import our necessary libraries for Python. I am going to import CSV because all of this I have listed in a CSV spreadsheet. Then I'm going to import the library called OS for my secret management. And then, as I mentioned, we're going to import PyNetBox. So the first thing that I want to do is I want to connect to NetBox. And one important tip about secret management, never hardcore your secrets in your script. They should always be in your environment variables, and that's exactly what I've done here. I've exported my NetBox URL and my API token into environment variables, and it's already sourced right now. After we connect to NetBox, we have to connect to the NetBox API, and the way we do that is in a variable called NB, which is short for NetBox. We get the library that we just imported, which is PyNetBox, and we do PyNetBox.api. And inside the parameters that I'm passing they're the environment variables that I just exported, which is the URL and the token. And after line 14, we're all done and we're all connected to NetBox and its API, and we're ready to talk to NetBox. The next thing that we're going to do is we are going to open the CSV file that we have. And the way I do that is I do with open, and inside I'm going to pass the CSV file that I have. And I'm going to read all of that into a variable called CSV reader with dict reader. What does dict reader do? What it does is it's going to import each of the rows that we have, all the 10 rows that we have. It's going to read that, map it to a dictionary so that it's easier for us to go row by row when we're putting the stuff back into NetBox. Once we have loaded our rows into this variable, we're going to put that in a for loop. So we do for each row in the CSV variable that we just did. We're going to put everything in a try and except block. Now, try and except blocks are very helpful because let's say we're importing 10 devices today, right? Let's say our third device or the fourth device fails. We did something wrong. We're not doing something right, and it fails. The code doesn't just abruptly stop, right? It's going to put it in the except block, and it's going to run through all the devices after that. So it's very helpful to put everything in a try and except block. So in the try block, we're going to create the devices in NetBox. And the way we do that is in a variable called device, we do NB, which is the variable that we just used to connect to the NetBox API. And we're going to use an endpoint dcim.devices. Now, endpoints in NetBox, when you're talking to the NetBox API, endpoints are very important. In this case, for this example, I am working with devices, so I am going to use dcim.devices endpoint. Let's say, for example, you're working with IP addresses. Your endpoint's going to change. It's going to be ipam.ip addresses, and all of this is available in the NetBox documentation, in the PyNetBox documentation. And then after nb.dcim.devices, I have to mention the method that I'm trying to do. Am I trying to create something? Am I trying to delete something in NetBox? Or modify something? We're importing devices. They don't exist in NetBox. We're creating a new devices. So I'm going to do .create. And inside the .create, each of the header that I had in the CSV file, I'm going to read all of them in its own variable. So I'm going to read the name. I'm getting that from the CSV file. I'm going to read the status of it, the position, the face, serial number, device type, the role, the site, and the rack. Now notice, the last 4 variables, the device type, role, site, and rack, they're not read the same way as the variables on top. That is because these variables are objects in NetBox. These variables, I don't know if you noticed in the UI when I showed you the UI, they had their own sections in NetBox. These are objects in NetBox. So when you're trying to create a device with these attributes, you cannot just put in your own site. You cannot just create a new site, or you cannot just put in a new value for rack. These values have to already be existing in your database for you to use them while creating the devices. So if you look at the endpoint that I'm talking about, for device type, we're getting the device type of the device type that we had in the spreadsheet, which was ISR 4321. And for that, we're going to use this dcim.deviceTypes endpoint, and we're getting the IDs. For NetBox objects, we have to work with its IDs. So I'm getting the IDs for device type, device role, site, and rack. And then I'm going to do a print statement for my confirmation to know if the device has been created successfully or not. And if it's not, it's going to throw an error saying that there's an error creating these devices. So let's go ahead. I'm going to pull up my terminal and just if you enter. OK, now I'm going to run this demo. As it goes through the spreadsheets, the devices are being created successfully. Now let's go back into NetBox, into our 25Y row where they're supposed to be created. I'm going to refresh this page. And as you can see that these devices have been imported into NetBox, and you have a clear view of your rack. Let me go back to this. OK, so we're done with demo number 1. Let's go into demo number 2. In demo number 2, we are going to be updating device versions in NetBox. This is modifying stuff in NetBox. So we are going to identify all Cisco Firepower 4110 devices that are using the ASA 9.12 version and update the inventory in NetBox to reflect the new ASA 9.14 version. So what are we doing here? As I said, NetBox doesn't actually configure your devices for you. We want to know which devices on the network are using 9.12. And we're going to use this script to pull all the devices that are using the version 9.12. And we're just going to assume that we have done these upgrades using an Ansible playbook or another Python script. Now that you've updated these devices from 9.12 to 9.14, we have to update this information back into NetBox. It's very important to keep your source of truth accurate. And that's what we're going to do today. We're just going to assume that we're going to pull these devices that are using 9.12. We're going to assume that we made these updates using an outside tool. And then we're going to put this information, 9.14, these devices that are using 9.14 now, back into NetBox. So let's see how we can do that. Hold on. I'm going to go back into my... actually, let me show you, before I do that, let me show you in NetBox. Actually, let me go back to my demo. All right, I'm going to go into my demo first. OK, so this is my script number 2. If you notice, the first 13 lines are the same. We're just connecting to NetBox, and we're just connecting to the NetBox API. And if you notice, there's no CSV file. We were not using any CSV file because we're modifying stuff. We're pulling stuff from NetBox, and we're putting that stuff back. After line 13, after we connect to the NetBox API, I define the variables that I need for this script today. That is the device type, the old version, and the new version. And these are objects in NetBox. So these values right here, they have to already be existing in NetBox for you to work with them. So my NetBox database right now has a device type called Firepower 4110, and it has a platform version of 9.12 and 9.14. Now, the first step is we have to find all the Firepower devices with the old platform version. And the way we do that is in a variable called devices to update. Same concept, nb. We're still working with devices. We're still trying to pull devices from NetBox. It's dcim.devices endpoint. But the method changes because we're putting conditions. We need a specific device type with a specific version type that we want to filter out. So inside the filter, we get the device type ID of the old version of Firepower 4110, and then we get the platform ID of the old version, which is ASA 9.12. And I'm going to uncomment these 2 lines because I want to see where the devices are located. So I'm going to run this script. OK, so we have 5 devices that are using 9.12, and they're located in Richardson in rack 25Y. Now let's go to rack 25Y, which I was in. OK, if you see the top 5 devices, they're all firewalls, and they're all using 9.12 version. Now we're going to use the same NetBox script to update them to 9.14. So let's go back to our script. So I'm going to comment this back because we don't need to see them anymore. And once we do that, Okay, now we have these devices. Now we're going to assume that these updates are done, which is outside the scope of NetBox and outside the scope of the script. So now we got these devices, we've updated them to 9.14. How do we update NetBox? Okay, the first step is we have to get the new version type from NetBox. So in a variable called new platform, we do nb dot, your endpoint changes now, it's dcim dot platforms, and your method changes because we're just trying to get the version that is in NetBox. When we're getting the new version, which is 9.14 that we define here. Once we get the version, we have all of these devices that we just listed in the variable dot called devices to update. So in the variable called devices to update, you put all of that in a for loop. So for each device in this device to update variable, you do device.platform. We're working with the platform attribute now. A device in NetBox has a lot of attributes, as we've seen. It has site, it has a rack, it has role, it has everything. But here, we're trying to update just the platform attribute. So we do device.platform, and we assign it the ID, because we're still working with objects. So we assign it the ID of the new platform, which is 9.14 that we just pulled from NetBox. And then we do a device.save, and I'm going to do a print statement just for my confirmation. And I'm going to run the script again. And it says, I'm going to pull this up a little bit. It says that I did update, it updated the platform for these devices to 9.14. I'm going to go back to NetBox, and just to confirm, I'm going to refresh this page. On the right side, you could see that everything changed to 9.14. So that ends my demo for today. And please complete your session evaluation. It is very important for me to know how I did. If you think it was good, I was bad, or if you want to see something different in the future, please do your session evaluations. These are some prizes that you win for doing your session evaluations. Continue your education. These are some mandatory slides that you're going to see at every presentation that you go to. So have fun at Cisco Live. There's so much going on. And any questions? Yes?
Library included in Pip. Can you just get it from Pip?
Yeah. Yes, you can. You can get it from Pip. Any other questions? Yes? Can't hear you. Uh-huh. I'm sorry?
Does that go to GitHub, or how did you update your devices from VS?
What do you mean?
Like the script you ran?
Yeah. Yeah.
Yes. How did you get it to connect to the devices?
To the devices?
Yeah.
I didn't connect to the devices. It doesn't configure the devices. This is a place of documentation. We're just updating the documentation. Yeah. But you could connect to devices using another Python library. You can connect with me on LinkedIn. This is my LinkedIn, and that's the picture of me in the data center for the first time. And you could scan this to get all your slides and demos. There's raffle tickets underneath your seats. You guys can win something, a T-shirt, or you could pick whatever you want. So under your seat, it's not that difficult to find them. They should be right underneath, or right in front of you guys. Huh? Not everyone, probably like two. There's two. Oh, someone found it. Thank you so much. Thank you.
All right. Can everyone hear me okay? All right, wonderful. I can hear me too. Let's go ahead and get started. So this is Intro to Event-Driven Architecture. My name is Colin Lacy. I'm a senior software engineer with Meraki Hardware. This will not be about Meraki Hardware. This is the overall event-driven architecture. All right, so let's dive in. All right, as with every other session, there is a Webex room. Feel free to join, ask questions, right? We'll be moderating until June 7th. So what are we going to talk about today? Well, we're going to start with what is event-driven architecture. Start with the definition, go from there. We'll look at what it takes to build event-driven systems, right? Get into patterns and practices by way of a demo, and then talk about some real-world use cases, how Cisco uses it, and how you can use event-driven architecture within your network. So, definitions. Right? So this is a definition from Confluent, and that is a company created by the people who built, created, invented Apache Kafka. All right, so event-driven architecture, I'm just going to paraphrase, right? Software design pattern that allows systems to react to real-time events as they happen. Okay, so the second an event occurs, right, information about that event itself, right, is sent to all of the stakeholders, all the systems that need to know about that event in order to process it in real time. So in this definition, just right here, you can see real time mentioned twice, right? So that's obviously a key factor of event-driven architecture. But overall, this is a little generic, okay? So let's take a look at what that means. Right, so first you have upstream systems. That means systems that are going to produce events, right? And those events are going to get consumed by downstream systems, right? So these are the vocab words, produce and consume, right, that are typically used in event-driven architecture. And in the middle, between your producers and your consumers, you have a message bus, right? That's the intermediary that facilitates the data flow between them, between your producers and your consumers. So we can say message bus, you might hear event bus, event broker, I've heard enterprise bus, right? There's a lot of phrases. I'm going to refer to it as message bus for the duration of this presentation. More often than not, you'll find event-driven architecture in microservice-based systems, right? And we'll talk about what the benefits are of event-driven architecture, and you're going to see that it really benefits microservices as opposed to monolithic environments. Right? But because you can have multiple consumers subscribe to the same event, you can kick off parallel automated workflows, right? And you can compose those workflows based on the data streams to fit multiple use cases, right? So you can really get into automating as much as possible based on the data, the events that you're getting. That might sound like pub sub, right? So I just want to take a sidestep here and talk about, this is not just the publisher subscriber pattern, right? And we'll talk about what the difference is. So in pub sub, the subscriber is generally aware of who is raising the events, what is raising the event, right? So textbook pub sub example is you have an application that's watching a file for changes, right? Or it's watching a directory for changes. Okay? And in order to create that relationship, the application knows which directory it's watching. If you want it to watch multiple directories, you have to rewrite that application to watch multiple directories, right? Well, in event-driven architecture, the subscriber isn't listening to the origin of the event, it's listening to the message bus, right? So that intermediary creates an abstraction point so that the consumer doesn't ever have to know where the producer or where the event came from, right? So there's no direct relationship, which means you can scale to multiple use cases. And we'll get more into that in a second. But when we build event-driven systems, we need that message bus. And by far, the most popular message bus that you're going to find is Apache Kafka, right? It is an open source tool. It's maintained by the Apache Software Foundation. It was created at LinkedIn. The creators left LinkedIn to create a company called Confluent, and they still contribute to it today. It was written in Java, but despite that, right, there are software development kits, SDKs, written in almost every language, right? And they're all open source. whether they're maintained by the Apache Foundation or maintained by the open source community. Right? When we talk about Kafka, we're specifically talking about a Kafka cluster, which means a series of servers called brokers that can scale out as much as you need to handle high throughput and high availability. Right? So whether it's hundreds or thousands or millions or even billions of data points streaming through your Kafka cluster, you can scale to whatever size you need to handle your data. There are other message buses out there. I don't want to just say Kafka is the one you have to use, right? You have RabbitMQ is another open source message bus, right? There are also proprietary, right, commercial message buses like AWS Kinesis. And there's also commercial offerings for Kafka, right? Confluent, again, right? They have their own commercial offering called Confluent Cloud. Or Azure, AWS, they have their own managed Kafka service that you can use, right? So MSK is Amazon's managed service for Kafka, right? That's what MSK stands for. And this is what, you know, a generic typical system design looks like. So in the middle, you have your Kafka cluster, right? And when I say cluster, again, it's a series of Kafka servers called brokers, right? And they act as the intermediary between your producers and your consumers. So producers push events to topics, right? And the Kafka brokers handle those topics by ensuring they end up, the events on those topics end up at the consumers that are subscribed to those topics, all right? So again, consumer subscribes to a topic, again, interfacing with the Kafka cluster, and the producer pushes data to a topic. And you can have multiple producers push data to the same topic, right? You can also have multiple consumers listening on the same topic. And we'll go into some of the patterns of what that looks like. Now, not pictured here is Zookeeper, which is responsible for managing your Kafka brokers. That is a whole discussion unto itself. All right, but this is a simplified view. So what you have here, if one of these servers goes down, one of these Kafka brokers goes down, you have a backup that can still handle that throughput, right? So that's why the topics are spanning multiple brokers. So that cluster affords high availability for you. So we've talked about events, right? Well, what triggers an event? And really, what is an event? And the honest answer is it's anything. Anything that's worth raising awareness about can be an event. Okay, so some examples. An entry in a data stream is an event. Right, so if you're streaming telemetry data, streaming database change logs, system logs, each one of those entries is an event. Okay, and again, it all happens in real time, right? You can have time-based events, right? If you have a process that spins up on cron, right, on a schedule every 30 seconds, every 30 minutes, that can spin up, raise an event, and spin back down, right? And again, that's producing into the Kafka cluster and then being consumed on the far end, right? Any time to live expiration. If you have a Redis cache, for example, with time to live expiration set on the entries, as soon as that time to live expires, you can raise an event to repopulate your Redis cache. And then finally, point-to-point requests, right? So a REST request, a gRPC request can be the starting point of an event-driven workflow, right? And the most popular way to approach this is with webhooks, right? So a webhook is an indication that something happened somewhere and you post it to a REST endpoint. From there, that REST endpoint can turn it into an event, push it to Kafka. So I bring this up, webhooks. Does Cisco offer webhooks in our platforms? Right, the answer to that question is yes, right? So if you create a chatbot in Webex, right, a Webex chatbot, every time you send a message to that chatbot, it can raise a webhook, right, and post the message that you just sent to an API. Thousand Eyes, right? If your network has different events, it goes down, it comes back up. Those can trigger webhooks that you can configure in Thousand Eyes, right, to post that information to an API. Splunk, you can configure to watch for certain data coming into your data stream, right? And if it recognizes certain strings, if it recognizes certain data points, it can raise a webhook to whatever destination you want it to go to. And then Meraki, is full of webhooks, right? Almost everything in Meraki, any event that can happen in Meraki has a webhook tied to it, so you can post that data wherever. And that can all post to a producer that can turn it into an event-driven stream. All right, so let's talk about some of the patterns now by way of a demo. So this is our demo setup. I've got a little system, right? And that's me. I'm this user right here, right? That's my specific to me, here's where you are. And I've got a workshop UI. It's a very simple React application, nothing fancy. But what this UI does is I'm going to push this button. And when I do, it's going to post. Remember, I said an event can be triggered by a REST API call, so I'm going to raise a post request to this producer. It'll turn what I post into an event, push it into the message bus, right, our Kafka cluster, and then our consumer is going to receive that message. And on the back end, right, my workshop UI is going to periodically ping every second this consumer and say, did you receive any events? All right? So let's see what that looks like. I'm just going to send some events. And as I'm sending them, they're getting pulled down, right? Pretty straightforward. So we can see that, all right, I push events to my producer, or I push requests to my producer. It can convert them into an event, get consumed. You might be wondering what's the point, right? If I was going to raise a post request, why didn't I just post it to the consumer from the beginning? Well, one of the benefits of event-driven architecture is I can come in here and I can shut down my consumer, right? And I can keep on sending events. Now, right, the producer is pushing events onto the message bus. Right now, there's no consumer running. So I can send these events. I've already sent 4, and now 5, 6, 7, 8. Nothing's happening, right? Well, if I turn this consumer back on, and I come back in, they were all received as soon as the consumer came back up, right? That's Kafka doing what it does best. Kafka handles that fault tolerance in your system. So if your consumer goes down, Kafka's keeping track of whether or not it received those messages, and it's storing them internally to handle fault tolerance. So if you're, right, if that consumer goes down and it can't receive that message, it'll wait until the consumer comes back up, resubscribes, and pushes that data that it hasn't received yet. Okay? So that fault tolerance is a huge advantage over REST. So let's take a look at our next example. All right, so here we're going to be working with consumer groups. All right, meaning we're grouping consumers together or separately. In our first example, we have 2 consumers, consumer 1 and consumer 2, in the same consumer group, meaning this group is listening to a topic. Not just an individual, but a group is listening to a topic. Okay? So I'm going to start up a second consumer here. And if I come into my UI, you can see 2 consumers, right? This no longer says offline, and they're both in the first group. So based on this, what do we think is going to happen? I can't hear you. They're both going to get the message? All right, let's find out. 1, 2, 3, 4. They're actually getting split. Right? So what's actually happening is Kafka recognizes that there's 2 consumers. Right? And that's a concern. Exactly what you said. If they both got the message, right, then we would be processing the same event twice within the same consumer group. Right? But instead what's happening, I can keep doing this, right? What Kafka is going to do is it's going to split the traffic between the 2 consumers in the same group so that the group only receives it once. And the benefit of that is high availability. We know things are going to go down, right? We know servers are going to crash, things are going to go bad. So if you have multiple consumers like this, right, what Kafka is going to do is it's going to make sure that group, great, it's going to get each event once. And that's how you can scale to make sure, scale horizontally to make sure that if one of these goes down, you still get to process data. Well, what happens if we have different groups? 2 consumers in different groups. Right. only one of them is going to, now is when we're going to see, right? I'm going to shut this down. And here, when I shut this down, watch this. So this is back offline, right? Kafka's going to rebalance to make sure that now all the events go back to the only consumer that's running. So Kafka's keeping track of how many consumer groups and consumers in each group are watching. Okay, I'm going to clear this out. Nope, not there. Here. There we go. All right, come back here. Now we can see they're in two different groups. Okay, so now what do we think is going to happen? Now they're both going to get it, that's right. So we've got timestamps on these, right? And the consume timestamp, you can see 142, 144, 796, 796. Within a couple milliseconds, they're both receiving them at the same time, right? So this is how you can, and this is called the fan-out pattern, where one topic fans out into multiple consumers so you can trigger parallel processes or parallel automated workflows. Okay? Let's get a little more complicated. We'll look at an advanced pattern, but before we get into that, so far we've been talking about a producer as a producer and a consumer as a consumer. In real-world production environments, you're more likely to see something like this, right? Chaining events where you have a producer that kicks off a workflow. Whatever event they send to the message bus gets consumed by a consumer. Great. This consumer is going to do whatever it needs to, right? It's going to run whatever processes, whatever workflows internally. Maybe it's going to add some data to that event. It's going to modify the event, and it will raise a subsequent event to be consumed by a downstream consumer, right? And it can keep on going. It can keep on chaining. And when you combine this with fan-out multiple consumer groups, you can start to build complex systems, right? One of the more complex patterns that we're going to look at is called the saga pattern. All right? And with a saga pattern, I'm going to walk you through this. I know this is a bit of there's a lot to look at. What we're going to do is we're going to raise an event that'll be consumed by this provisioner. And in the saga pattern, you have something that produces the event, also eventually consumes the workflow back into itself, right? So it's a loop all the way back to the starting point. And in this example, we're going to onboard a new user, right? So we're going to click a button in our UI, right? We're going to onboard a new user, right? Our producer will raise an event in our new user topic. Great. It'll be received by this service, our provisioner. So we're going to provision them a laptop. Once they have a laptop, we'll raise an event to an authorizer that'll authorize them to be on a certain VLAN, right? Or wherever else they need to be authorized. And then from there, once they're authorized, we'll raise an event to the notify topic. And that notify topic will say, let's notify this user that they've been authorized now. You have a notifier that will send off an email. And once they've been notified, right, this will raise an event on the notified topic, which will be consumed by the provisioner. So here's our loop. Here's our saga. All right? A saga pattern can be just one step. It can be multiple steps like we have here. Now, for demo purposes, right, I've got our UI is running get requests to APIs on each of these services. In a real-world production scenario, you're not going to do this, right? You're not going to be watching each step along your automated workflow, your event-driven system, right? But this is just to show we can see the events as they flow. Now, what I want to highlight here is event-driven systems are, by nature, asynchronous, right? If we have multiple instances of each one of these, we're going to get different processing times at each step, right? The authorizer, so let's say this is running on we have two instances, they're running on two different servers, right? One might push data faster than the other, right? One might get data faster than the other. So we can't guarantee the same throughput time each loop through the saga for each event. Right? Now, this is normally going to to the tune of milliseconds, maybe seconds, right? I've added in, again, for demo purposes, a significantly longer delay. But what that's going to show you is, as we onboard new users, right, we're going to see these new users complete at different times. And that's real. It really works this way in production, right? Not this slowly, where it takes Indira and Francisco multiple seconds to complete, right? These process in milliseconds, right? But as they're completing, you can see that they're completing at different rates, right? So that this throughput isn't exactly predictable, but it will complete eventually, right? And that's one of the reasons you don't want to be watching in suspense. You just want to let it do its thing in an automated workflow. All right. Real-world use cases, right? So that was a demo. Let's talk about real-world use cases where we, in Cisco, use event-driven architecture. Well, first, easy example, Cisco U. Cisco U works. There we go. Cisco U works on event-driven architecture. Every time you complete a course in Cisco U, multiple workflows are triggered, all through Kafka, right? Updating your learning history, prompting new recommendations, right, for what to do next. Generating any course continuing education credits, right? If you complete a course that has CE credits associated, right? And if you complete a course that has a digital badge, right? All four of those steps are just triggered by one single event. You completed a course. In DevNet, right? When you register or when you reserve a DevNet sandbox, multiple processors are triggered, right? We want to make sure you're authorized. We want to make sure the resources available to facilitate the sandbox that you've requested. We want to make sure that you're not reaching a limit for how many concurrent sandboxes you've registered. And finally, there's the actual spinning up of the Docker containers necessary to fulfill your sandbox, right? And that's a lot on its own. But maybe the most iconic use case that I was able to find is the Thousand Eyes outages map. Okay, so at the beginning, I focused on real time, right? Event-driven architecture is data processing in real time. So that's how Thousand Eyes works. It takes global outage data. We're getting a bit of a lag here. There we go. So global outage data, and it aggregates it through Kafka into one single display in real time. So as events happen, billions of data points processed daily. As they happen across the planet, they're being pulled into this one Kafka pipeline and being displayed in this map in real time. The Thousand Eyes folks love Kafka, right? And they've got a blog. If you scan this QR code, you can see some of their blog posts about Kafka. I will warn you, they are quite advanced, right? But you can see just how deep this subject goes just by looking at their blog posts, right, in terms of things like Kafka management and Kafka use cases. I'll give you guys a second. There are more QR codes, so keep your phones out. All right. So the use case that you might be interested in for your networks, model-driven telemetry. All right. You might have seen diagrams similar to this one, right? We have iOS XE has a built-in capability to raise gRPC dial-out telemetry, right? And in multiple learning labs in DevNet, on the Cisco Catalyst Center product homepage, you'll see examples or links to examples of how you can build out this system. And there's a white paper here, right? If you want to scan the QR code, that talks all about it, right? But what it does, this gRPC request goes to a gRPC server, and the example that they use, or the stack that they recommend, is the TIG stack. So Telegraph, InfluxDB, and Grafana. Telegraph is a gRPC server. It can receive gRPC requests, and it pushes those requests into a time series database, InfluxDB. And then once it's in there, you can use Grafana, which is a visualization tool, to visualize what's going on in your network, right, and see it on your computer. So that's great, and that's a totally valid system design. I don't want to knock it in any way, right? But you might be a little busy, and you might not be watching your Grafana dashboard at all times. You might just want to know, hey, did something happen? Get notified. Well, you have a different option. Instead of feeding it to InfluxDB, Telegraph has an open source connector to Kafka, which would turn Telegraph into a Kafka producer, right? You configure it, and this QR code goes to the GitHub page that shows you how to configure Telegraph's Kafka connector, right? To push data into Kafka. And now once it's in Kafka, what can you do? Anything, right? You can automate as many workflows as you want based on the events as they come in. Remember, Kafka handles data streams. That's what it does best. So as those data streams come in, each one is an event, and each one can be processed individually. So maybe, simple example, right? Let's start small. Telemetry comes in, you want to raise a notification, right? Maybe you're watching for specific strings in your telemetry data, specific data points, and if you see a data point, great. Let's send an email to one of our network engineers, let them know what's going on. That's great, that's an option, that is totally a valid workflow, but it's a little boring. Maybe instead, or alongside that, we want to feed our telemetry data into Splunk, right? Splunk has an open source connector to turn it into a Kafka consumer, right? And this QR code goes to the page that shows you how to configure the Kafka connector so that it can be a consumer, not just on one topic, but multiple topics, okay? So you can notify, you can consume that data. Maybe you're consuming it just as a log aggregation. Maybe you're consuming it just to, not just to, but maybe you're consuming it to train an AI model. Great. But you want to react too, right? Well, Ansible has a Kafka connector, also open source, right? Which this QR code will take you to that page. So event-driven Ansible, that's what Red Hat calls it. You can configure Ansible to watch for events as a Kafka consumer, and that will trigger Ansible playbooks. So you can notify, you can store events, and you can react to events, all just off the existing functionality that's built into iOS XE, right? Using open source tools. So where do we go from here? Well, this topic is very big, or this subject, I should say, right? Not to confuse the terminology. So from here, you can look at more advanced patterns in event-driven architecture. We didn't discuss the fan-out pattern. That's huge for data aggregation into a single pipeline. We didn't discuss error handling at all, right? The demo was very, very carefully crafted so that everything would go right. But what if things don't go right, right? What if some of those users never actually completed the onboarding process? Well, error handling is a big subject in event-driven architecture, and just so you know, error handling can be its own event-driven workflow. An error can be an event. We didn't talk about security either, right? So there's a whole discussion we could have around how you secure your Kafka clusters, how you secure each topic, right? You probably don't want your topics to be wide open for anything in your system to subscribe to, right? So there is a whole aspect of Kafka management. In fact, Kafka cluster administration as a whole is a very, very big topic, very advanced and very detailed. You could look at alternatives. Again, RabbitMQ, right? AWS Kinesis, there's tons of information on how to use those. And then from there, even if you don't want to look at any of these other aspects, you can just look into, think about what other use cases that you can get into for automating, what other workflows you can automate based on the events in your system. Okay? So, as with every other session, right, please complete your session evaluations. I do take all the feedback seriously, so please, feedback is welcome. Right? Continue your education, of course, right? Tons of resources around here, Cisco U, obviously. If you want to connect with me, I'm not a social media guy. I don't tweet, I don't talk, I don't gram, right? You can find me on LinkedIn. That's how you can find me, and that's where I respond. Or, of course, the Webex room. And that's it. There is a raffle, a giveaway, right? So there's tickets under 2 seats. In front of the seats. So look around, maybe an empty seat, right? And there's a giveaway. It's a t-shirt and a travel mug, I believe. All right, we got one. Thank you very much, everyone. Thanks for coming. I hope you learned something.
Okay. Okay, everybody, hello. Thanks a lot for attending this talk. My name is Phil Bellanti. I'm with the Webex for Developers team. I'm going to be presenting integrating your business with Webex. This one's not going to be a real technical talk. Usually with Webex for Developers, that's what we're used to doing is, talking to developers and about developer enablement. I've been working with the Webex for Developers team since I joined Cisco in 2015. So it was called the Spark platform then. I don't know if anybody remembers that, but, oh, very good. Yeah, so the original Spark, but my current role covers, all the Webex platforms, all the developer services. But today, I want to talk a little bit more about the business value of APIs and the integrations that you can build with that. This is going to be a little bit of a departure than what we usually do for our introductory sessions for Webex for developers. But I'm going to talk about like integration workflows on the meetings and calling side, and then on the administrator and compliance APIs, and then for bots and messaging. I'm going to talk about use cases. I'll talk about some of our partners, and just some general things that you can build with our platform. But really, to start off, if the question is, can Webex integrate with a particular service? The answer is almost always yes. And the reason is because Webex has a comprehensive collection of APIs, or application programming interfaces. And what these are, it's kind of like Webex building blocks that we give to the developers to allow them to build all kinds of great integrations, to customize workflows, get work and tasks done easier. It also increases like customer stickiness inside of a particular application. So let's say if everybody's doing their work inside of Webex, now you can bring even more of that to Webex. Make everything kind of easier to get. When you start out on a task and things like that, jumping from application to application sometimes slows you down. Having everything inside in one app is good. And it doesn't even have to be just in Webex. These APIs can also power custom applications, outside of Webex. So people can, maybe they're using another application through healthcare or banking, and we're going to talk a lot about that. But ultimately, because of our large collection of APIs, we can build really, really powerful integrations, and it's very, very flexible for the developer. But I've already said integrations probably about 5 times. So, what am I talking about? When I say integrations, the integration as far as Webex goes, it enhances your account. Okay, so when you have an integration, you have to give it permission. People are probably already very familiar with this. If you connected something to your Google account or something like that, it's using something called an OAuth grant flow. But these are the permissions that an integration would need to use, before you start using it. And then once you give it, the permission, it can act on your behalf. So it can post messages on your behalf. It can schedule meetings on your behalf. So again, this is for, a particular user, in Webex to enhance their experience. That's essentially what an integration is. Now, if I was doing a very technical talk, we'd be talking a lot about like what each of these API endpoints do, all the parameters and things like that. But I just wanted to kind of show this to you just to illustrate these. This is just a collection of the most popular sets of APIs to work with the Webex suite. Okay, so meetings, messaging, calling, administrator, and compliance. But these are again sets of APIs. So there's many, many, some of these have 10, 20 different endpoints in there that do very, very specific things. But it's all like, writing to something, reading something, deleting something, or updating something. But as you can see, there's many, many different areas. Pretty much everything in Webex can be extended. which again can build some really, really great integrations. And many of these integrations are shared by our partners on the Webex App Hub. So we want to, once you build this great integration that you think others would benefit from, or you want others to discover your service, then you can build an integration and you can get it published on the App Hub. It goes through a technical review process, a business review process, and once it's on there, really potentially it could be discovered by millions of different Webex users, so they can be introduced to your business through this way. But I'm going to give you a few examples from each of those platforms, messaging and meetings. There's a listed on our App Hub, so you can kind of see some of our partners that are building with us already. So in the first section here, I'm going to talk about Webex meetings and calling integrations. So all the use cases in this particular section, most of them are working in conjunction with other third-party platforms. Okay, so you're usually, when I'm saying integrating, you're integrating with some other service. Okay, but just to kind of level set here, with Webex meetings, familiar with that. This also includes Webex webinars, all the video teleconferencing things, all the video collaboration. That's what we talk about with Webex meetings. And then with Webex calling, this is our complete cloud calling system. Everything that it comes down to setting up an office, locations, everything. That's going to be for Webex calling for devices, phones, things like that. But I'm going to start off with, on the Webex meeting side, on healthcare, because that's usually one of our biggest verticals when we're talking about integrations. And the biggest one being telehealth consultations. Especially during the pandemic, that's really popularized them. It's a healthcare application. Now, the APIs allow us to not only just embed the Webex meetings inside of that application, but you can also control all the meeting stuff in there. And it also integrates with electronic health record systems like Epic. So now, doctors and patients can get everything done as they would if you were live inside of Webex. You can, share imaging. You could share all kinds of records or care plans inside there. But it's similar. Maybe instead of like just a consultation, you'll have a little bit more of a care management type of application. Maybe somebody with a chronic condition. They're at home and now you want to, maybe the doctor wants to always check in on them, so they'll do regular checkups with them. Perhaps they're using some diagnostic equipment, and together they can read these diagnostics together, and if they need to adjust their plan, they can do that. But again, the APIs make this all possible, so you can do all that sharing right inside there. Rapid response with healthcare. If there's some kind of urgent urgent thing that happens, or there's an alert in the equipment, they can quickly assemble the care team that needs to come together and fix the problem. We have an API that can create instant meeting connections. So you don't have to start doing that and worrying about do they actually have Webex set up or anything like that. You can get an instant meeting connection and you can have everything done right inside of a browser. And then also for wellness support programs, personalized coaching and therapy. And then also, because like I mentioned before, Webex meetings also includes webinars. So maybe there's some wellness group sessions that you want to get organized together. You want to streamline your registration workflows. All those things can be automated inside an integration with our APIs. But just to give you an example of a partner on our App Hub, Cloverhound Connect for telehealth. So they did a really great telehealth app. It was the first example that I mentioned. Nearly every electronic medical record system they can integrate with already. So really, you can just start using this right away. Any medical facility can start using it. They don't have to rebuild their app. But Cloverhound's using our meetings APIs in very intuitive ways to build this application. To get any more information, it's over on the Webex App Hub, apphub.webex.com. And just to give you just a couple other examples, for education, instead of a virtual consultation, now you have a virtual classroom. Learning management systems that you can integrate with. So As soon as a student schedules their classes, it'll automatically use the APIs to schedule those classes as meetings. So now the instructors and the teachers will all have everything done inside of one application, all automated inside there. They don't have to worry about setting up each one of their class sessions. Everything's all automated through the APIs. And very similarly, like the remote office hours advising, you can set up an integration that'll automatically schedule these for you. And then in finance, we see a lot of use cases around secure document collaboration. So if you have like a contract signing or some sort of agreement, you could share all of those documents right inside of the meeting. The APIs will streamline all those workflows for you to do that. And now everything can be done right inside of one thing, and you don't have to leave the app to do a signature on your contract. Everything can be done right inside that meeting. And then in government, I think the most popular we're seeing here around the remote court proceedings. We had a partner that built something. It was even pre-pandemic. It was for the New York State workers' compensation. Basically, they wanted to take those working compensation hearings out of the court sessions and make them all remote, and it was a huge success. It freed up all the courts rooms. It freed up parking spaces. So it allowed them to do everything right inside there remotely. And it's all powered by Webex. So all these things can be done. You can keep all of your meeting resources, like your recordings and your transcriptions, right from the APIs, and you can archive them as well. And we'll talk about that when we get into our compliance section. But these are some really good use cases over on the meeting side. So just in summary, what we've learned here, the APIs can do scheduling and configurations. For automatically scheduling, it can get your recordings and manage that. You can manage your transcriptions. You can even get real-time transcriptions too. So you can do things like maybe like real-time, language translations, things like that, or for hearing impaired. The APIs control in meetings. So anything that you want to do inside the meeting to control it, configure. Maybe you want to change, you want to remove somebody from a meeting. You can do that automatically. You can manage all of your invites and registrations for webinars, and you can track your meeting insights data from like your transcriptions and your recordings. All that can be done inside there. And you can also do auto configurations of meetings through the APIs. Now, let's jump over to Webex calling. There are PBX in the cloud, okay? So in retail, we see a lot of really cool use cases around this. So for like an inbound customer service, we've all seen that where you need some intelligent call routing, maybe depending on like the urgency of the inquiry, maybe the caller's account status will get a special, this guy's a VIP, so we're gonna route them right to the front of the line. How long the caller was on hold. These are all can be integrated with your customer relation management systems. Okay, so you would integrate your customer relation management with Webex, and you can use that for your call routing. Now, shopping assistants, maybe like a high-end retailer, they want to do some VIP customer consultations. Before a VIP customer comes in, you want to make sure that they're going to have everything that they need. Maybe a personal shopper scheduling. As soon as hey, I can't make it over there, but I want someone to do my shopping for me. You could do some scheduling around that. But again, we see these a lot in like high-end retailers. And then this is a really good one: floor staff communications. Think of a large or like retail or big box store like this. The floor staff has to communicate with the back of the house. And a lot of times they're picking up courtesy phones and things like that. But now with our APIs, they can just route these calls from a customer service to the floor staff, through extension dialing that just rings their mobile phones. So now that enhances your floor staff communications inside of especially big stores. And then for order and delivery, we see a lot of things working with dispatchers. We need to, hey, where is this delivery? Oh, actually, I'm going to need to change the delivery address, but hey, the delivery's already out. We can have an integration that sets up route changes so you can get these calls into the dispatchers and then they can relay that over to the drivers. Maybe there's some specific delivery instructions they need to give them on the fly. Now, a good example of a partner who's using calling APIs is BroadSource. And they use our calling APIs to allow people to, their businesses that don't have a call center that can collect credit card payments. You need a PCI compliant environment to do that. And if you don't have one and you try to get it, it's very expensive. It goes through a long auditing process. And sometimes it's just out of the reach of many businesses. Or maybe you don't even have a call center. You have people working in their homes, in like a virtual call center. Well, this allows them to take the credit card payments over the phone through basically it transfers silently to a PCI compliant environment. The representative and the customer do not hear any of these things going on. Even when they collect their credit card information, it all stays private and it's all done in a compliant way. So that's a really good use case. You can check them out on the App Hub if you want more information. But on the calling side, we see in healthcare, they're doing it auto dialers to schedule up their follow-up visits, right? So maybe you gave somebody a care plan and you want to follow up on that care plan to make sure that they're adhering to it. And then, in finance and banking, perhaps they notice some kind of fraudulent like transactions. So what they can do is whenever they kind of detect that, they can start sending a phone call to whoever's card that was and get that verified. And then in government, like a real good one is the public alert system. You want to send an urgent message to your constituents, maybe a public safety alert for the affected citizens. You can set up through the APIs an auto dialer that plays like an audio file, for example. But to level set on the calling APIs, most of those use cases I talked about were around like call control. Those are the user level actions, right? But there's two other pillars that are very, very important here. The provisioning, which is setting up, a calling organization. And then we have reports and analytics, and that's for getting all of your call reports and details. Both of those two are administrator APIs. So we're going to get into the administrator next, but a lot of those other use cases, this is the only one. These are on the user side. Okay, so there's no administrator APIs here. So now onto administrator and compliance integrations. These are for like special user roles. So on the administrator API side, this is automating everything inside of Control Hub. So administrators, when they go inside a Control Hub, they can add a user one at a time. They can set up a device one at a time. They do a lot of clicking inside there. But when you're setting up an organization with hundreds, thousands of users, with many, many devices and locations and things like that, you really need an integration. So let's focus on, since we're already talking about more calling and telecommunications, in integrations that do dynamic call plan updates. Dynamically adjust call plans based on when they change their service. So if somebody changes their service agreement, then their APIs will automatically start doing a configuration onto their call plan. So if customer selects a new service, the APIs can automatically update it so an administrator wouldn't have to go in there and do that manually. Customer auto provisioning. So as soon as a customer opens up a new account, it'll auto provision their account using the APIs. When they subscribe to a new service, the API can provision features, it can assign phone numbers, configure voicemail settings. So anything that they knew they subscribed to or changed, that can be all done through auto provisioning. It can also do device management. So I think specifically around firmware is a really important one. You want to keep everything in the same version. You want to keep your configurations, very, very consistent. You want to make sure that they're all the same. So these APIs allow you to do very consistent configurations. Make sure everybody is up on the same, all the devices are up on the same versions. And then we have like bulk enterprise configuration. This is, for very large enterprises, they need to do things in batches. So let's say they want to manage their call routing and hunt groups for their entire organization. It's a very, very long process if you're doing that manually. But with the APIs, you could do that very, very quickly. And to give you an example of a partner that's working on our app hub is on Myobi. They streamline all the reporting that comes out of Webex calling to power dashboards. And they can also, basically organize all of your, reports for you. And they help you track all of your key metrics inside there. So this is a really great way to quickly and effectively organize all of your reporting from Webex calling. And then with the administration APIs, we also see a lot of like HR management systems doing integrations with that. So you can update. Anytime that something happens with an employee change a role, those could be updated quickly with the APIs. Any new org policies they take place, you can now change those in bulk. And another really good one around the reporting side, we have an API that basically gets your call history. So between 5 minutes after the call ends to 48 hours, you can obtain your call detail records. And then you can build a billing system from that, so all automatically. Now, another special user role is the compliance officer, and we have APIs that help out with their roles too. So, as you can see, a compliance officer isn't necessarily an administrator. An administrator has to assign a compliance officer, but a lot of times they have like a special role. Compliance officer can access generally any kind of content inside of your organization. They can read your messages. They can access your recordings. So this is a very, very powerful user role. So it makes it very much different than an administrator. But on the compliance side, we see a lot of use cases over in finance. So fraud detection. So if there's suspicious keywords that come up in a recording or inside of your messages, they also can track anomalies in user behavior. So if there's something strange going on, we could flag that for future or for more investigation. Transactional record keeping, regulatory compliance. So a lot of banking regulations require you to archive all of your communications, and with the compliance officer APIs, you can do all that. Prevent unauthorized info sharing. Potentially maybe the investment group is talking to the research team, the research and design team. There might be some conflicts of interest there. So perhaps we put up an ethical wall with the compliance API integration. And then insider trading communications. If you see any insider tips coming through inside of any of your communications there, flag that, delete the messages, or or do a more investigation. And in the App Hub, a classic use case of the compliance APIs is from our partner Theta Lake. They do long-term archiving, and this is really at every layer of your communications. But they already are very, very well versed in all of the regulations globally. So you kind of take all the guesswork out of it. You can just feed all of your information into Theta Lake's system, and it will take all of that for you. So you don't have to worry about it. But again, they're using our APIs to build this. And the compliance APIs help healthcare. Let's say you're all of a sudden sharing some MRI imaging or X-rays. They probably is going to contain some pretty sensitive information. Get that flagged on there to make sure it's only being shared with the right people. For freedom of information requests for government, the public records archivals. So you can archive all of your communications inside of Webex so they can comply with the Freedom of Information Act requests. And then on the legal side, maybe during the discovery phase of litigation, you can use the compliance APIs for searching of communication data like messages and meetings recordings and transcriptions. So now on to bots and messaging. And bots are like another, another user, because they're kind of their own account. So in bots, when we're talking about bots, we're really talking about messaging inside of Webex. So when you see a bot and you start using it inside of Webex, you'll see have a little bot name in their avatar. This particular one is for a bot that we use a lot is for Cisco acronyms. We have 1 million acronyms inside Cisco. You try to Google some of them and then you'll get like 50 different results. But if you ask the Cisco acronym bot, he gives you the Cisco-centric definition of what that is. So a lot of these bot use cases are, we see them, they're kind of like transactional bots, meaning they're kind of doing like one specific task. So for these bots, let's just say like, you're going to assign team tasks to somebody. So they can follow up on that team member after you assign the task to make sure that they're actually doing that work. And you can tell the bot, yep, that's done, and then it can report back to your leader. A scheduling assistant, we see bots that come in there to say, who do you want to invite to the meeting? And then it'll find all the right times for them, and then it'll start suggesting them for you. So meeting suggestions. Sales lead generation. We've seen a lot of like chatbots in the front end of like websites that kind of like pre-qualify new leads that come in. And then that bot can notify your sales team, hey, there's a new visitor coming in here that wants this, this, and this. And then they can jump right in there and start helping out that visitor. And we see a lot for like supply chain. They did to do inventory queries. So you can quickly ask a bot by putting in like a SKU number or a product name, and it'll give you, your inventory management, from the warehouse, for example. Other use cases we see a lot in like IT, security incident responses very, very quickly. You can come together inside of a space and have that bot deliver all of the information you need to fix the problem. An automated help desk, a bot that's using natural language, so you can talk to it just like you're talking to a human. So you can free up a lot of your other agents to do other things with an automated help desk bot. And then, in media, we see a whole bunch. Maybe you want to have like a bot that delivers, there's going to be an all-hands meeting next week. I want to make sure everybody's there. Have the bot deliver this in an announcement space. And one of our partners, Reserto, they have a great bot. And then it allows you to kind of feed your knowledge repositories inside there, so it can give kind of contextual questions and answers. Support teams, customer service teams, sellers can use this. So when someone asks them a question and they don't know the answer right away, they can ask the bot and they can get that answer and information from them very, very quickly. And with our messaging bots, they can give a graphical user interface called buttons and cards. That makes it much easier to communicate with the bots. You can see there's many different ways you can make these cards, but again, it's much easier than doing everything over text. You can collect a whole bunch of information at once. But where to learn more? For developers, developer.webex.com, we have a lot of great documentation. We have an entire support team dedicated just for our developers. So it's not just regular like technical support. This is these are our engineers, our developers that are helping other developers. They answer you less than 20 minutes. And it doesn't matter even if you have a paid Webex account or if you're just some developer off the street, we're going to help you all the same. We have a great community forum. So if you want to start a conversation with some of our experts or the rest of the Webex community, you can go and see our, and there's the URL right up there. But our support team's in there, our engineers are in there, I'm in there. So and there's really, all of our partners, customers are communicating inside there too. So we definitely recommend you checking that out. We have a booth over at the Webex exhibit. We're doing some great demos over there. We already did a couple already in the mornings. But at 4 o'clock, go back to that one. We're going to be doing one on contact center desktop widgets. Tomorrow we'll do one on Instant Connect, which is what I was kind of talking to you about the API that you can set up a quick meeting. Contact Center Flow Designer, and then we're going to do another one on our AI Assistant preview. I'll do these two tomorrow. I'm going to build a little chat bot at 12. I'm going to deploy a service app an hour before that, and we're going to be talking about the meetings SDKs at 3. And that'll be on Wednesday. But again, apphub.webex.com, that's where our partners are sharing their applications, our developer community. The Webex Contact Center, I didn't mention anything like that in this session, but they have their own developer portal right now. It's kind of separated at this point, but developer.webex-cx.com. There's a lot of great sessions going on for that too. And then as far as samples go, we have a lot of code samples, templates and everything. So if you want to get going quickly, you can start using some of these samples in there so you can hit the ground running. And that's the end of this talk. So if you have any questions, you can find me right on the Webex app, or you can always pull me aside. I'll be over at the Webex booth this week. And don't forget to complete your session evaluations too. And before you go, we have one giveaway. They said, in front of your seat, if you just lift it up, if you find a blue ticket, oh, there's 2 of them. If you find that blue ticket, oh, there you go. We have one right there. You can redeem it right over here with these nice people. All right, we got another one. Great. All right, thank you very much.
Alrighty, good afternoon everybody. Thank you all for joining. My name is Camden Shevitz. I am a product marketing manager here at Cisco, and I'm joined on the side by our software engineer, Mike. And today we're going to be talking about a new automation product coming to the Cisco networking cloud. The goal of this product will be to unlock a new set of capabilities across our core controllers to help simplify your operations and streamline your tasks. So with that, let's begin. Again, the purpose of this session will be to understand the root of complexity with Cisco and with network management in general, and then go into how Cisco is solving for this. We'll have the chance to demo this product and see it in action, and then, if time permits, we'll do some question and answers here at the end. So, as you all know, network management is growing in complexity. And a result of this is because the scope of IT responsibilities is growing along with it. Between access networking, WAN, the data center, IoT, observability, our customers are reporting that complexity is one of their top concerns. This complexity not only slows down your progress in your operations, but it creates real burdens in the form of misconfigurations, error-prone processes, and increasing your exposure to cyber risk. And Cisco has historically not helped with this. If you guys take a look at the laundry list of dashboards and controllers we offer right now, it is clear that while we have 40 years of experience in building some industry-leading networking products, we come across as siloed, and not all of these dashboards play nice with each other. So we'll go into how there needs to be a better way to go about this. We view automation as the answer to simplifying your operations, and cross-domain automation is nothing new. For the past 20 years, our customers have turned to third-party products such as Ansible, Terraform, and so on to build complex, code-heavy work streams that help automate the day-to-day operations across various systems. And as we look towards the future, the Cisco Networking Cloud will help with this. As we work to consolidate our cloud platforms and our on-prem platforms, we're looking to unify the experience across the portfolio and move towards platform consolidation, both with Catalyst and Meraki, as well as our data center offering, and we're currently working on this with our security products as well. But network management will never be truly one size fits all. We'll bring together our offerings into fewer dashboards. We'll help solve the underlying complexity of operating a lot of Cisco products. Network management will always be complex. And this is where we look to automation to help tie together work streams across both Cisco and third-party applications. We view automation as the glue that holds the network together, and we are aiming to provide the simplest experience possible for customers committed to Cisco networking. So our plan moving forward is to focus our investment in expanding the Cisco Networking Cloud beyond just an idea. Today, I'm proud to announce the first big step we're taking in making this happen. Cisco is bringing automation in-house to allow our customers to streamline their operations across various domains without having to bounce from dashboard to dashboard to configure and provision your equipment manually. This new automation tool, which we'll dive into here in a second, will help roll out services faster without making the delivery of these services a multi-step, multi-hour, multi-meeting ordeal. Cisco Workflows is our plan to bring this to life. Our plan to do this is to offer a powerful automation capability that you can find natively from the Cisco Networking Cloud. Pardon me. Cisco Workflows offers a new set of features to the Cisco Networking Cloud that will help streamline automation across all of your domains. Workflows is a cloud-hosted automation tool within the Cisco Networking Cloud, and we're trying to put simplicity first by offering out-of-the-box automation templates to provide cross-domain automation to various network tasks. With Workflows, customers can leverage either Cisco-provided automation templates that are based on Cisco-validated designs, or create their own in a low, no-code environment. To my point earlier, this product is greater than just Cisco on Cisco, and customers can orchestrate automation both across Cisco and third-party domains. To dive a little bit deeper into that, some of the adapters supported include Catalyst Center, Catalyst SD-WAN, Meraki Dashboard, Thousand Eyes, ACI, and so on. But we realize there's a deep reliance on third-party ecosystem partners as well. And Workflows will allow you to automate tasks across ServiceNow, Infoblox, even your existing automation platforms such as Ansible or Terraform, to create one unified experience for automation across the entire network. An example of this, which we can see here, would be using Workflows to automate a mixed branch environment where you might have a Catalyst SD-WAN appliance at the edge, say an ISR, and you have Meraki for access, so an MS, MR across the campus or branch. And you want to set this branch up while also integrating out to ServiceNow for ticketing in the event that something breaks. With Workflows, you have one dashboard that allows you to set the branch up from day zero on without having to go across Catalyst SD-WAN Manager, Meraki, ServiceNow. How our customers can use this product, on the far left, we have an automation hub that provides templates grouped by outcome for various automation tasks. And what we're doing here is essentially bringing CVDs to life and allowing you to deploy them in your environment in only a few clicks. If you would like, you can take that framework and modify it using the drag and drop designer to tweak to a specific use case. So we provide you the framework, and you can modify it as needed. Or you can leverage generic REST or SSH adapter to build your workflows entirely from scratch to reach just about anything. Some of the examples of various outcomes you can expect with workflows could be the automation of configuration or policy management, PCERT and drift detection, integrating workflows across domains, across multi-controllers, or multiple controllers and agents. And before we get into the demo, the best part about Cisco Workflows is that it is entirely free. So if you're a Cisco customer operating a Cisco management console with an active license, then you can find us in the booth in the back. We'll get you signed up for early access, and you can unlock the benefits of Cisco Workflows at no cost to your organization. That includes all the adapter support that I mentioned earlier, the out-of-the-box templates that we base off of Cisco-validated designs. This gets you SSO and identity access management support and integration, and integration into the cross-platform navigator that lets you run the workflows from our UI and then validate them across whichever controller you're running them to. So yeah, that is all I have for you guys. I'm going to hand it off to Mike to run through a demo, and then we can wrap things up with the Q&A. Thank you.
All right, thank you very much, Camden. Did you already hit play on this? All right, so folks, it's one thing to talk about workflow and automation and what it means and what's involved in it, but we'd like to do is show you how it works. So we've recorded a live demo, and I've annotated on top of that to kind of give you a feel for what's going on. You're going to see a lot of information. Don't worry too much about all the details. We have a booth that you can go over to, and we can show you exactly how these things were built. But this will give you an idea of the power of workflows that you can put into somebody's hands. And as a test, and in case my boss is watching, there's 2 typos on the annotations that are here that I put here on purpose. They're going to look like grievous, awful misspellings. They're not. That's just me testing you to see if you're following that. All right, let's see if we can do this properly. All right. So we're going to walk through the live demo now. The first thing I'm going to show you is the topology. So this is what we're going to try to deploy with a workflow. We're going to take a Catalyst edge box, connect it to an L2 Meraki box, and hang 2 switches off of that. We're going to do this all via automation. We're going to pull down the automation from a shared space that Camden told us about and download it into your personal tenant workspace. This is going to be your free account that you created. Here in that account, I have a folder with all the automations that I pulled down from Cisco from the Automation Hub. You're going to see a bunch of different workflows here. The first one we're going to work on is deploying the actual branch. And then we have some others we'll do. So we're going to run this workflow right now and talk about what it's doing. So we run the workflow, again, from our SaaS offering, and I'm going to start to fill out information. You're going to see I want the name of the branch, and then we're going to pull things from inventory. What's really cool here is that workflows will pull out of the controller the cache inventory information. So I need to know what SD-WAN switch, what SD-WAN configuration. Those are pulled down live from the controller. I can then choose the one I want and then go into my Meraki inventory. Which Meraki devices, which one are my switches, which ones are my access points. So I'm already working across 2 domains here. If I want to, for those of you who know Meraki, I might want to clone from an existing Meraki network, in which case I can hit the clone button, another pull from inventory. So as the workflow automation person designing this, I can make this very easy to understand where to get my data. So I'm going to run this workflow, and what you see is a run monitoring screen that's showing you every single step of our automation. Now, before I deploy, what my workflow is going to do is it's going to go up to the Meraki cloud, and it's going to check, are my devices there? Are they available? Are they online? Are they already claimed to another network? These are things my operator would want to know before actually deploying a branch. Same thing with Catalyst SD-WAN. Let's step inside the Catalyst SD-WAN sub-workflow and see what it's doing. So it's going to go and do the same thing. Is my vManage device there? Are my controllers up? Because if these aren't working, then I might as well stop right now because it's going to fail. I'm going to go in and actually deploy the branch now because the first tests have succeeded. So what am I doing in here? I'm going to retrieve from my smart account my device. I'm going to associate it with an SD-WAN configuration template that I'll then apply parameters to. So that's all happening now in my timeline. And you can see now I'm stepping through the main workflow, deploying my Meraki switch, my Meraki access points, and bringing up my entire wireless networks. So these are all happening as each step of the workflow. Now that workflow may or may not be done yet, so I could say, hey, I've deployed my branch because my workflow automation is run, but what we're going to do here is run another workflow that's going to do a post check. So what this workflow will do is go through and see, is my branch truly up? Now that's a really quick activation. There's no way it's going to be up. So we're going to see here down the bottom that this actually failed. So if me as an operator who doesn't have access to the controllers, I can tell somebody, hey, that I've deployed your branch with mixed Catalyst SD-WAN and Meraki, but that WAN uplink is not enabled yet, so I can't give you the thumbs up. But what if I wanted to actually go into Meraki and check that out? If I have RBAC, I can use the Cisco Platform Navigator to use my SSO credentials to cross-launch into Meraki. So here I am in Meraki, and there's my new branch that's coming up. So what we'll do is a couple of validation things to see what we automated, because that was a lot of stuff going on. So the first thing I'll look at and see is my VLAN profiles. The Meraki network is my L2 network. The Catalyst SD-WAN is my L3. There's my APs. There's my switch. So these have been assigned to default profiles to set up my VLANs. Let's take a look at the switch that's deployed. There's my Meraki switch. We've named them according to our workflow to a naming convention. And that's up. Now what you notice down here in the LAN IP, this is getting its IP, its DHCP, from the Catalyst SD-WAN box, and that's also my gateway. Up here, I can see all my ports that are active, my uplink to my WAN and my 2 APs. By the way, notice port 8 is black, is not active. I tried to turn that on and it didn't come on. Let's come back to that. So my trunk is up, it's open and it's negotiating. My switch seems to be doing what it's supposed to be doing, and it's speaking to my Catalyst SD-WAN box. The wireless APs, they're doing their job. We have 2 wireless APs. Again, the IP addresses are coming from the Catalyst SD-WAN box because that's where my L3 network is happening. So I have 2 networks that have been deployed, employees and guest access. The guest access is on a different VLAN, so that is secured, being routed up to my Catalyst SD-WAN box where it's being put into its own VRF. So I'm isolating that traffic out. And I can look at the details to see the different frequencies I'm broadcasting on. So this is all good. It looks like my basic configuration's all been pushed here. This is what the post check was doing, by the way, just to give you a comparison. So let's look at the topology that was deployed. I have 2 APs hanging off of my Catalyst switch, and that diamond on the far left side, that's my Catalyst SD-WAN box, which I can see from the Meraki dashboard, and I can see that's running my iOS SD-WAN operating system. So this looks good. If I didn't have access to that Meraki dashboard through the navigator, then I could just go back at another time and let's rerun the post check. This is going to do the exact same thing we just did, but it's doing it through automation workflows. So now the workflow is going to run again, and it's going to go and check all those same things. Is my Catalyst SD-WAN in sync? Do I have all my configurations? Is my switch deployed? Are my wireless networks deployed and up? And that's what you're seeing here. So this passed. My operator doesn't have to go into the controllers to see all this information. So this looks good. However, if we think about it, that port 8 was not active. And I did happen to notice that I might be getting calls now that says, hey, you deployed my branch, but my IoT devices, they're not running. Nothing's online. So I'm going to run another workflow. It's a cable test. What this workflow is going to do is it's going to go up to the Catalyst SD-WAN switch, and it's going to test every port on that switch, which I got from my inventory pulled down, and see what's going on. So right now I've made a request to Meraki that says, go test every port on that Catalyst SD-WAN port that I switch that I deployed. That succeeded. It's going through, it's checking the results, and we got a failure. So this is why that port was dark. If we click on that failure, get the details, we can see exactly what was going on. So down here we can see this failed because the cable, which I went in with scissors and cut, is failing because we have open pairs. So we've gone into that cable. I've cut a couple of wires on that, and we've detected right there. You can see the return. If you needed this type of detail, if that high-level information was not enough, I could look and get the status of every pair on that cable. So using workflow automation, I've gone through and I've deployed in seconds, really, because that's a real-time demo. I've deployed an entire hybrid branch. I've done pre-checks before the deployments happened. I've deployed the Catalyst SD-WAN box, connected it to a Meraki L2 switch, set up my trunk ports, set up my access ports, set up my Wi-Fi networks, and then I've done post-checks to do diagnostics on a bad port. All of which I don't necessarily need to know anyway how that was done. So if I wanted to know how that was done, let's see how I get to my next slide. If I wanted to know how that was done, come over to the world of solutions. We have a demo booth over there, and we can actually break open these workflows, and we can step you through these adapters and tasks that Camden talked about that span our technology domains. So we have adapters that interface with every one of our controllers, third-party controllers, and they'll show you exactly how we can speak and generate the outcomes that you saw in this demo with just a drag and drop, low-code, no-code solution. Very easy to do. A reminder, this is a free solution. It's going to be announced tomorrow at the keynote speaking, and it'll be a free offering to folks coming this quarter. All right, before we leave, there's one other thing. There's a giveaway prize. These nice people over here have hidden underneath some of these seats. You'll see a blue tag. If you look under your seat, and maybe an open seat around you, if you find that, there's going to either be money or a blue tag. Some will be cash prizes, and some will be blue tags. Nobody found the blue tags yet? There's one. Has anybody found the $100 bill yet? Nobody found the $100 bill yet? I know which one it's under, and I see the person not looking, but I'm not going to tell you who it is. So if you found the blue tag, it's under there. Bring it over to these nice ladies right over here. They'll give you a great cash prize to go along with it. And again, thank you for your time. If there's any other questions, I think we might have a couple of minutes. Either myself or Camden can answer them for you, depending on how your time is. We'll stick around afterwards, and feel free to come up and we can talk. Oh, we got a question right here. Good question. The question was, who do we speak to get access, maybe early access to EFT or public trials? There's a gentleman right in the room right here. Ryan, if you raise your hand, you can come over and speak to that gentleman right there. He has the keys to the castle. Get you signed right up. All right, if there's no questions, folks, thank you very much. Enjoy the rest of the show.
All right, can everyone hear me? Okay, if anyone cannot hear me, we can turn this up to 11, I promise. Unless I get too close to this. I'll stay back here, I think. All right, welcome everyone. You are here to learn a little bit about Ansible. Am I right? You're in the right place? All right, good. First of all, I appreciate that you all came here at 4 o'clock right when the reception is starting. So thank you very much for sharing your time with me and with reception. My name is Palmer Sample. I'm a highly caffeinated developer advocate with Cisco Learning and Certifications right here. I'm on the Cisco Training Boot Camps team, which we focus on automation and programmability, whether it's for SDA, enterprise networking, Meraki, ACI. We also do operations and troubleshooting boot camps. So thank you all very much for coming in today. Today we're going to be talking about Ansible. Now, I need to set this expectation. This is not an Ansible deep dive session. We're not here to really get into the behind the scenes of Ansible. What we're here to learn about is, what is this thing? You know, someone came to me about 6 months ago and they said, you know, you talk about this, you talk about Ansible, but what does it do? I'm studying for a certification. I'm working on Enterprise Network Core exam, and we have to know this, but I don't get it. I don't know what it does or what it can do for me. And that inspired me. I thought, let's demystify some of this. Let's bring some of this to you, and let's make Ansible not an intimidating thing at all. In fact, you're going to see it's very easy. But we're going to talk about it from a certification standpoint. The key terms, the key concepts you need to know to be successful in your certification journey. Before we get started, if you do not have the Cisco Cisco Events app, go ahead and get that. You can join the discussion. That will add you into a Webex space. So each one of you will be added to a Webex space. We can continue this conversation after Cisco Live. If you have questions about Ansible or you're working on something, you need clarification, post it in there and I'll keep an eye out for it. What we're going to be talking about today, we're going to learn what Ansible is. We're going to talk about some key terms that you need to know, some key concepts. We're going to look at basic requirements to use Ansible, and if we have time, there's a chance you might get to see me fail in a live demo right in front of you. And that is always the best part of Cisco Live for me. So first of all, a little bit of background on Ansible. Ansible is an automation tool. It's an automation tool. It was written in Python. It's still written in Python. All of the back end of Ansible is written in Python. But you do not need to know Python at all to use Ansible. Okay? It is open source. It's designed for, now this is an important term, configuration management. Configuration management. And we talk about something called infrastructure as code. Anyone heard that term? Infrastructure as code? Maybe kind of, sort of familiar with it, not sure. When we talk about infrastructure as code, what we talk about is being able to maintain our automation tooling, our tool sets, our playbooks in Ansible in something like a Git repository, something that we can share. We will treat our automation tools as though they're development source code, like the developers and the programmers do. We're going to treat our network automation that way. So it's our infrastructure maintained as code. And Ansible was designed for server configuration management, Unix, Linux, Windows, VMware. But you can see it's become very, very popular with networks. What do we need to know about Ansible? Is anyone here studying for an exam right now? Certification, all right, yeah, good. Got a number of hands, all right, so key terms. You might see something like this in the exam topic list. Agentless. What is agentless versus agent? Ansible is agentless. What is an agent? When I say agent, think about something that is running on a system. If you think about your laptop or your maybe a server, virtual machine, maybe you have backup software, a backup server at work, and you schedule jobs and it reaches out and it contacts a machine, and there's some piece of software that you install on every server that's the backup agent, and that communicates with your backup server. That's an agent. Now Ansible is agentless, meaning it uses native protocols such as SSH or HTTPS to communicate with our device that we're going to be configuring. I don't need to install anything on that device. I'm going to use, Ansible will just connect to it based on information I tell it, and we're going to see how we do that in just a minute. And where Ansible is running, that is called the control node. The control node. The things that we are interacting with are called managed nodes. And Ansible has the ability to work with a number of Cisco platforms and other things, Linux, Unix, like I said. If you're running ACI, it can communicate with the APIC. If you're studying for enterprise networking core, maybe you need to know about Catalyst or Meraki. So we have a number of options, and again, we'll talk about how we do that in just a moment. So Ansible is responsible for establishing the connections, managing configuration. And it's based on a really cool mathematical concept, which we're about to get into. But the next term is push model. You might see in the exam topic list that there is a push model versus a pull model. So we talked about agent versus agentless. The difference between a push model versus a pull model, and actually, I'm not even going to get into the difference. We're going to talk about a push model because that's what Ansible is. Ansible uses a push model. We said we define our infrastructure as code. Now, once we have that defined, our playbook, and we can use Ansible, Ansible will run on that control node. It will connect to our destination device, and it pushes configuration to that device that's going to be configured. That is the push model. So if you notice, from the control node, we can use SSH, again, maybe SSH or HTTPS if you're using RESTconf, or just a standard REST API, or if you're interacting with APIC. We have many options, but the control node, managed nodes, and it's a push model. Next thing that you're going to see, this is all about Ansible. In fact, if there's one thing you need to know about Ansible, it is this. There is a way of writing text, just plain text, using indentation and some structure to represent data structures. Has anyone here heard of JSON? JavaScript Object Notation. All right, a lot of people have heard of this. So you may have seen something like this, all of these curly braces, or as one of my colleagues calls them, mustaches. Or these, we have a dictionary here. We have a list. Tasks is a list of dictionaries. So that is our JSON representation of an Ansible playbook. JSON, YAML. I can represent any of this JSON content as a different file format called YAML. And the only thing here that we're really concerned about is indentation. If you notice, this is a screenshot from a text editor. See these lines that show that we're indented? In this case, it was 2 spaces. These dashes here, a dash indicates a list element. An indentation represents key value pairs or a dictionary. So tasks is indented. Tasks is a dictionary. Actually, it's a list of dictionaries. So here's our first list element. And the dictionary, name, and then Cisco iOS hostname. So we have key value pairs. Learn about YAML. It seems complicated at first, but once you can learn YAML, that is 99% of Ansible. It's all about the YAML. So if you want to be successful at your next certification exam with automation technologies, learn about that YAML. Idempotence. This is, remember a moment ago I said, hey, there's a really cool mathematical concept that Ansible uses, and that's called idempotence. And what that means is, given the same input, once the state is changed, repeating the same task will not create a new state. Think of it this way. We're all here in Las Vegas at these huge buildings where our rooms are high above the ground. And we come up and we press the elevator button to go up, and we're waiting for the elevator. I have given the control system input. I push the up button. That has created a state. The elevator is on the way. Has anyone ever seen anyone do this? They push the button 5, 6 times. Come on, elevator, come on. Every time they push that button, that is not doing anything to the state. It doesn't make the elevator come down faster. I have given the system one input. The elevator is on the way. Every time I push the button, it is not changing the state. So an elevator button is idempotent in that sense. In this case, what this means with our network automation is Ansible will only change something if it needs to be changed. If you look here, these are really the same things. Configure the host name. But see how the output looks a little bit different between these two? It says the same kind of text, but we have some colors and we have some other information. We changed the host name to Cisco Live Router 1.ciscolive.demo the first time we ran this playbook. And it comes up and it tells us, okay, one task was okay, it was successful. One thing was changed. Well, this playbook was one thing, so I know it was successful and it changed the host name. The next time I run that exact same playbook, it is green here. It says, okay, we're going to set it Cisco Live Router 1.ciscolive.demo. But this time it's green, and it says, OK is 1. It was successful. Changed is 0. It didn't need to do anything. That's idempotence. So I can run the same playbook over and over, and I can tell if something changed. Maybe that means that it was configured out of band by someone. That never happens in our world. Everything is approved. Change management, nobody touches devices when it's not approved, and we have everything documented in real time. Right, sure. Genja 2. I said if you can learn about YAML, you know almost everything there is to know about Ansible. Here's the rest of it. This is what else you need to know. Genja 2 is a templating engine, a Python templating engine. Now, when I say a templating engine, what I mean is I can create some type of variable. I can define something. In this case, we have a variable called ntp config, and we have a couple of servers. We have a list of 2 servers. That's great. I have an ntp config. What can I do with that? Well, I can use it in my Ansible playbook. And we're going to talk about playbooks in just a second. And if I wanted to, there's a built-in module here called debug, and all that does is print something to the screen so I can see what happens. And my message, look, ntp config. Well, okay, that's the variable name. But how do I get the contents of that variable? How do I access that? How do I print that? I enclose it in quotation marks, and then I do those double curly braces to open and close. So this says, hey, Genja 2, this is something to be translated. This is a variable. I want you to use the variable ntp config. And when I close this, then it says, okay, I'm done. When Genja 2, when Ansible runs this, then what it's going to do, it's going to replace everything here, including the quotation marks, with ntp config. So it's going to replace it with the contents of this variable. For example, when I run that, then this is what it prints. Remember I said that message says print something to the screen, debug message. So message, and here's what it's printing. It says servers is a list with 2 servers. Servers is a list with 2 servers, 254, 253. So that Genja 2 template, it took what I wanted to print and it translated it and made it into something usable by the program, by the playbook. There are a few requirements that we have to actually get started with Ansible and to use it for network automation tasks. First, we need an inventory. how to contact it, and we can define some variables in there. We just showed a demonstration of a variable with Edge Engine 2. We can define some variables in our inventory. So here, our inventory starts with all. That means everything in the world that Ansible knows about, it goes into all. We have to have everything in all. That doesn't mean we have to target every device, but we have to define our devices. Our first host, Cisco Live Router 1.ciscolive.example. We have this, the host name here, so that would be our DNS name. You know, easy enough. I know how to connect to it. However, sometimes I do not have DNS for a host, or it might be behind a proxy. In my case, at my lab that I was using, I did not have DNS configured. So what I did is you can define this special variable Ansible host and give it some way to get to it, IPv4, IPv6 address, you know, proxy, whatever you need to do. But this instructs Ansible, here's how you get to this host. User and password, that is our credentials. Here it's in plain text. There is a tool that you can use to encrypt credentials. It's called Ansible Vault. That is not listed in your exam topics, but it is there for you. And if you're going to use Ansible and play with it, learn about the Vault, Ansible Vault. So we could use encrypted credentials. If you notice, remember I said that YAML is all about the indentation? See how hosts and vars are at the same level there? That means that the variables down below are going to apply to all the hosts. So I'm saying, here are the NTP servers for all hosts that Ansible knows about in the world. We can take that inventory and we can take all of those hosts and we can create groups of hosts. So if I want to target, or if I want to configure or interact with only my iOS XE hosts, I can create a group. Now see where it says children? I said all is every device. We can have children of all. That means, okay, all is the parent, and that's everything in the world. Children, we can have groups. In this case, we're creating a group called XE hosts, and we tell it which hosts are assigned to this group. In this case, Cisco Live Router 1.ciscolive.example. And again, that YAML indentation, the variables here are the variables for the host in the XE host group. So the Ansible connection, I tell it, use the network CLI. This is a connection plugin, and this tells Ansible, this network CLI, it tells Ansible, you are going to be using SSH to interact with this device, and you're going to be interacting via the CLI. Okay, well, how do I know which CLI to use? Guess, maybe? Figure it out? Try to break the network? No, we tell it Ansible Network OS, and Ansible has a number of plugins, a number of vendors, manufacturers create plugins or connection packages, and here we can say the network OS is cisco.ios.ios. So now, in our inventory file, we had how to get to the host, credentials to connect to the host. We know it's going to use the CLI, so SSH, and it is a cisco.ios device. Now, it sounds like we've got enough to actually do something. And what we do, we use modules. An Ansible module is a small Python script that's just designed to do one task and one task well. That's it. You don't have to know Python to use these modules. But here's a sample from some of the modules that are available for that cisco.ios.ios collection. You can see iOS ACLs, BGP, BGPAF, or address family. We have our interfaces, layer 2, layer 3, host name. We have a whole list. You can scroll down and see all these modules. And we can use those to do any number of tasks on our device. Now, if you look at APIC or Meraki, there are going to be different modules, but you have these whole collections of things that you can do to configure your network and manage that configuration. When we look at the module, it will give us documentation, and it says, hey, there's a parameter called config, and a parameter named hostname, and config is a dictionary. Hostname should be a string. And this is what we need to provide to that module for it to work, for it to actually perform some configuration. So when we define it, we would say cisco.ios.ios hostname. Config is a dictionary, so config. And then notice the indentation, this is a dictionary. And then hostname is a string, so hostname is those little curly braces, Jinja 2 template syntax, inventory hostname short. And this is a special variable in Ansible. And what it does is it takes the hostname component of the fully qualified domain name, gets rid of the .example.com in our case. So we just set the hostname to Cisco Live Router 1. Modules are used in playbooks. You've heard me say playbook a few times. And you might be sitting there saying, what is that? All a playbook is, once again, it's in that YAML. It's YAML formatted text. And a playbook defines tasks that are executed in the order that they are specified. This is important because when you are designing your playbooks for configuration management, for configuration using Ansible, you have to make sure that you have things in the correct order. For example, if I were to assign an IP address to an interface and then specify that that interface should be placed into a specific VRF, does anyone know what happens when you do it in that order? Yeah, IP address information for the interface has been deleted. Whoops. Great, well, at least it's in the VRF, so I'm 50% of the way. No, you have to make sure that you have the order of operations that you're going to use. And tasks, look, we've got this key tasks, and notice below it is just a list. That's all it is. We specify a name, and the name is just used when it prints out the report at the end, or it tells us what it's doing. And look, we just saw this. That's a module. Cisco iOS hostname, iOS NTP global. So our playbook defines tasks in an order for them to execute, and those tasks generally are going to be modules, which are just small specialized Python programs. And it's not magic. I just went to the documentation and read, okay, config and hostname, I need those keys. Config and servers, okay, I need this. Let's just plug it into this YAML formatting with our indentation, and we have built a playbook. And we run the playbook using the Ansible playbook command. Oh, here's where the rubber meets the road. Let's see if this is going to work. Fingers crossed. All right, everyone can see this? People in the back, you can see it? All right. We are on a device called Router. Nothing configured for NTP. I don't even know what else we have here. Oh. Okay, that's a very good typing skill right there. Include domain, okay. So this is just a freshly installed Catalyst 8000 virtual running as a VM locally. I've got a simple playbook that has some of the tasks that we just looked at. People in the back, can you read this? All right, thumbs up, good. I asked again because we had more people add up in the back. So the first thing we're going to do, we have hosts. We're going to target all hosts. And I'm doing this because all hosts for me is one device. I'm pretty sure that this is not going to consume all the resources on my laptop, but stranger things have happened. We're going to configure the host name. We are going to configure some NTP servers. Now, we did not cover this because I said this is not going to be a deep dive, but fortunately we have a couple of minutes left. We have control statements and conditionals in Ansible that we can add to a playbook. And one thing is a loop. When I say a loop, I mean iterate over elements of a list. And every time I iterate, and the way I do that, I say loop. Loop executes a loop. Jinja 2 syntax, I've got a variable named NTP servers in this instance that's a list of a couple of NTP servers. every time I iterate, every time I start a new iteration for the next element in my list, Ansible creates this special built-in variable name called item. I believe that JavaScript used or uses something similar for their loop iterators or their iteration variable. But so we are going to loop over every NTP server, and for every NTP server, it's going to create this placeholder variable called item. An item will contain the current NTP server. So here we're going to say server, the first NTP server. Server, the second NTP server. So we're just going to keep doing this until we get through the NTP servers and then go to the next task. We have some other modules here. There's one called iOS config. Sometimes you don't have a module available for exactly what you want to do. But that doesn't mean you're stuck. That doesn't mean you have to go to manual configuration. We have the ability to issue arbitrary commands like no IP domain lookup. Because everyone loves it the first time you log into a device, make a typo, and then you get to wait that 30 seconds, right? iOS config, if you notice it says lines. So I can add a list of lines here that are going to be executed on that device. There's no module available, just execute these commands. And some initial device settings. Notice there's another loop for console 0, lines VTY 0 through 4 and 5 through 15. Set an exec timeout and log in local. And then here we have iOS command. The difference between iOS config and iOS command is that iOS config enables configuration mode on the device. iOS command is just run in privileged exec mode. So if you want to run a show command or copy run start or write memory. So you would use config to create configuration, command to run show commands. Let's see if this thing actually works. I'm going to specify my inventory file. You saw that a few moments ago. And we're going to say config playbook.yaml. Okay, it says configuring the host name, configuring NTP servers. Maybe that output should be a little bit bigger. And it's configuring the initial device settings, setting the line, VTY and console lines, and it saved the running configuration. Let's see what happens here. What do we get? We get OK is 6. 6 things completed successfully. 4 things were changed. That's because this iOS command running the right memory, it doesn't make a change, so it just says OK. So that's not a change. Nothing was unreachable, nothing failed. That's maybe a first for me being on this stage. And nothing was ignored. Did it do anything? Our host name has changed. No IP domain lookup. We have a couple of NTP servers, so it changed the configuration on this device. Now in the 30 seconds or so we have left, what happens if I run this again? Should I expect anything to change? I see a lot of people saying no. Let's find out. Okay. Configure the host name, that's green. NTP servers, we've got a couple of them. Okay, it looks like things are going green. How many will say changed? I heard a 0. OK is 6. 6 things completed successfully. Nothing changed. Idempotence, there was nothing to change. So if you use Ansible to maintain your configuration, that gives you the ability to standardize what you do, and every time you run this, it's going to give me the same exact output. And if you see change, that means something happened that maybe shouldn't have changed. All right, everyone, I have taken up way too much of your time, and I thank you, but you can't leave yet, because there's still more to come. I have swag. And that's why, when I was a customer, I loved Cisco Live. Okay, so first of all, thank you all very much. There's going to be a reception here in the World of Solutions, and if you want to get into a deep dive with Ansible and you want to really get in there, come and see me about Cisco training boot camps and some learning opportunities. Also, make sure to check out Cisco U. u.cisco.com. We have tutorials on there that are free to anybody. All you need is an account. We're currently running what's called a Rev Up to Recert. You get a full learning track for Nexus dashboard. Dashboard. I completely forgot what I'm saying, but you can get 16 learning credits. But the important thing is we have options. You can either win a Stanley Cup, and I do not mean that great big trophy for hockey. It's, oh, Emma's got the Stanley Cup right there. And we've got a Cisco Live e-book voucher, and we've got a Cisco U something, shirt. Oh, pickleball set. And I think, hold on, wait, we have more swag. And a Cisco U shirt. All right, so you have the chance to win some cool stuff. Two of you right now, you're going to find a blue ticket like this. It would be under your seat. So let's see if we can start a riot here with people bumping into each other as they look under their seat for that blue ticket. Do we have any winners? I got a winner right here. Second winner, all right. Thank you very much, everyone. Thank you for your time, and enjoy Cisco Live.
Should we start? Oh, okay, awesome. Can you hear me okay? Yay, awesome. Hi, everybody. I hope you're given a great Monday and a good start to your week here at Cisco Live. Thank you all very much for attending this session after your probably very long day. I really appreciate it. My name is Katya, and I'm a product manager at Cisco Meraki. My area is identity and access management, and we will be talking about authentication and cyber defense today. Before I jump into the content, there's actually a couple of housekeeping items that I wanted to highlight. So we will not be doing a live Q&A today. However, I will be happy to take all of your questions via the chat that you can access through Webex. You can use the link that's at the top of the slide, use the session ID, and then you can join the discussion where we can answer all of your questions. So in that dedicated space, we will be answering the questions until end of this week. So June 7th is the last day when we can take the questions. What are we going to talk about today? So since this is an educational session, I will start by diving into kind of the introduction to the problem space first, and then we will talk about the current cyber threat landscape a little bit before we actually dive into the primary attack vector, which is digital identities, and then from there we will review the basics of authentication methods, and then dive into a little bit more of the advanced authentication methods, then we will do a conclusion, and then we will wrap it up. All right, so as we may all know, anything with an internet connection and a power source is potentially a victim for a cyber attack. Sadly, our personal computers, tablets, wearables, phones, and networks are assaulted every single day. I think about 33% of all logins that happen at any moment are malicious, which is pretty scary. But in recent years, due to the explosion in the Internet of Things, everything from our planes to energy grids to healthcare services to, again, like wearables and personal vehicles could be a victim of the attack and has to be protected. On top of that, we all now expect very convenient work from anywhere experiences. And that shift to hybrid and remote work models has also broadened the enterprise attack surface, subjecting companies to higher than ever risk of data loss and exfiltration across endpoints and SaaS applications. This rapid growth in mobile, cloud, and remote tools has permanently transformed how business interact into business. While this has paved the way for innovation, for new businesses, new business ideas, closer bonds between businesses across the globe, unfortunately, it also dramatically increased the digital attack surface. As it was stated in the last year's World Economic Forum Security Outlook report, in cybersecurity, attackers have a structural advantage. They need to find only one exploitable weakness across an organization, which means the attackers have less ground to cover than the defender. And the attacker can often adapt much faster than the organizations can recover or defend themselves. In the news, we keep hearing about those high-profile, really impactful ransomware attacks and data breaches, like, for example, the recent attack on the MGM Resorts, well, the financial losses were estimated to be about $100 million. Or the British Royal Mail, where the attackers, they demanded, I think, a hefty, like, $80 million of ransom or something like that, which may lead us to think that it's the large entities and corporations that are usually susceptible to being attacked by the hackers or cyber criminals. However, unfortunately, that is not the case. According to the FBI, as large businesses continue to increase their cyber defense and they invest a lot in increasing their security posture, the cyber criminals are pivoting. They're actually adapting to the new environment, and they start focusing on the softer targets, which is smaller to medium-sized businesses. And here's the number on the slide. So in the past year, 75% of ransomware attacks were actually directed in small to medium businesses, with over a half of those businesses actually going out of business in the 6 months after the data breach or some sort of attack happened. And a lot of the cyber attacks that the FBI has witnessed from the investigation, actually almost all of them, could have been avoided or prevented had the companies used just the basic cyber hygiene. With cyber attacks, unfortunately, it's not just about the stealing money or inflicting financial losses on organizations. It's also about stealing trust. When customers lose faith in your ability to protect their data, the financial losses may only be the beginning. Actually, 55% of consumers worldwide have stated that they would stop doing business with a company after a data breach, indicating that significant customer retention issues here are at stake when this happens. Now that we have established that no one is safe, now let's talk about how they get you. So digital identities remain the primary vector of cyber attacks. 90% of companies that were surveyed by SpyCloud actually reported an identity-related breach in the past year. Stolen credentials are still a popular tool for criminals to gain access to your systems and applications. And these days, digital identities evolving from your typical username and password combination actually point to the fact that the malicious actors, they would take and deploy any single piece of data that they can get their hands on. In the cybersecurity world, we keep talking about how the methods that the hackers use, they keep evolving and they're so sophisticated. However, it doesn't take much sophistication to log into your account when they already have your credentials. They really do not need any complicated techniques when they already got hands on your username and password, and which is why that makes it their most treasured type of data. And what's even more mind-blowing here is that each of those exposed credential pairs put your customer and employee account at risk, which is even worse given that there's a massive password reuse rate that is seen widely, and one set of exposed credentials can actually give malicious actors access to more than just one of your accounts. According to the reports, 3 out of 4 people affected by data breaches already reuse previously compromised passwords. On top of that, 2 out of 3 people who experienced an account takeover do not even enable any more security to their accounts, like, for example, your multi-factor authentication or security questions, which is everything that we'll be talking about today. Now let's talk about how we can protect ourselves from cyber threats to our digital identities. We will start with the basics. We'll actually start with the email password authentication and the ways that we can strengthen it today. So someone said that the security of your system is only as strong as your weakest password. So this could not be more true. So aside from using strong, unique passwords that you have to rotate pretty frequently, what else can you do to protect your identity? So you can limit login attempts. You can also provide training to your employees on cybersecurity. You can use VPNs, and of course, you can enable multi-factor authentication. Multi-factor authentication is already pretty widespread, which is really great to see. It requires users to provide multiple factors by coming up with something that they know, like a password, something they own, like a security token, and also something they are, like, for example, using the biometric verification. When it comes to multi-factor authentication, there are multiple options there, so we will review them all. Here, we'll go from left to right, and this, I guess, like from the least preferred ones to the more the stronger ones. So starting with email-based authentication, email-based multi-factor authentication, not good. Not good. It is the most vulnerable option that exists out there. If attackers gain access to your email account, which they probably will because they already have your credentials to access the other system, they will intercept all the MFA codes, password resets. This is not a recommended MFA option, even though it has a place to be. Next up is SMS. Super easy to set up and use. Doesn't require any other additional devices, just your phone that you can use. However, it also has some downsides to it. It is pretty vulnerable to SIM swapping and interception. Actually, cool story, my phone got stolen from me a couple of weeks ago. So naturally, I went to my service provider store to get my wireless line transferred from the stolen phone to the new one. I guess not the new one, but the old one that I actually found at home. And they did that. No questions asked. Not even an ID check. They just transfer the line from like one device to another, which is pretty crazy, also pretty terrifying. I could have been a malicious actor, but So yeah, so SMS, like super easy, not preferred. Another downside to using SMS multi-factor authentication is that it depends on the availability of the cellular network, which is not ideal. Raise your hand if you've ever been locked out of the company apps while trying to work on the plane. So, the struggle? Yeah, exactly. So, given those availability issues and also the security issues with it, SMS also is not a super great MFA method. Now moving on to the app authenticators, like for example, Cisco Duo is one of those. The great thing about authenticator apps is that they have the ability to work offline, so it doesn't really depend on the availability of the internet or cellular networks. Makes it super convenient in all kinds of situations. They are more secure than SMS because they send the code to your device. So unless somebody is in possession of your device, they will not be able to get that factor. More advanced apps like Duo, for example, they have that feature where they allow you to actually create an account and back up your data to cloud, which is really convenient in case you lose your phone. For example, or like the device they use with an authenticator, you can actually restore your account on a different device. So I highly encourage everybody to look for that feature when you select an authenticator app. There are options out there. There's the Cisco Duo, Google Authenticator, Authy, all those. So overall, authenticator apps, great option for multi-factor auth. Now moving on to the hardware tokens. Like for example, YubiKey, you're probably all familiar with that one. Very, very secure and very convenient multi-factor authentication option. They are the little devices, they're highly portable, super easy to use, they're a great option, they're very secure to protect your accounts. A couple of downsides is probably the cost. You'll have to invest in purchasing new hardware. Another downside could be that it's very tiny. Like it can be lost, it can be forgotten in the device. Unfortunately, sometimes you leave your laptop unattended and the security token is sitting in there. But other than that, really great option. And last but not least, biometrics. So biometric authentication. Very convenient, very fast, it's very secure because it uses your unique traits like your face or fingerprints, and it's super hard to replicate or steal. That's why it's highly recommended. However, you do need compatible hardware to use with it. There are also privacy concerns with it in case if there is the biometric data breach happening. Probably don't want that to. And then other than that, it's a really good option for multi-factor authentication. All right, so while multi-factor authentication significantly enhances the security of your accounts by requiring additional verification, one of the factors in that process is still your password. And we have established that passwords are the weak link in the entire authentication journey because they're very susceptible to phishing, interception, reuse across multiple sites, and the ease of being stolen, which is why enter passwordless authentication. Passwordless authentication aims to eliminate all passwords altogether, enhancing both security and user experience, which is amazing. Love that. It comes in several forms, actually. It could be the one-time codes. It can be also security keys like pass keys, and that is what I wanted to dive deeper in today. So passkeys, they use biometrics or hardware tokens, and they're enabled with such technologies as CTAP and web authentication. CTAP is the client to authenticator protocol, which facilitates the communication between the web application, between the user's device, like your smartphone, for example, or your computer, and then the authenticator, which is the hardware token or a biometric device. And then web authentication handles the interaction between the web application, actually, and the user's authentication device. Web authentication is an API developed by the World Wide Web Consortium that allows web applications to authenticate users securely using public key cryptography. It supports various authentication methods, such as biometrics, hardware security keys, and mobile devices. So like I said, passkeys, they use public key cryptography to embed digital credentials on a client's physical device, eliminating the need for hackable or stealable passwords altogether. Online accounts that use passkeys, they can be accessed the same exact way you would unlock your phone, so it would be your biometrics or PIN or like some certain swipe patterns that the user can do in order to show that they have the physical possession of the designated device. This method provides a highly secure form of authentication because the private key, and I will dive a little bit into that in just a moment, the private key in that pair of public and private key never leaves the user's device. So how passwordless, how passkeys work. So at registration, when you first register the device, your device, be it a smartphone or computer, a smartphone in this case, it generates a unique cryptographic pair of a public key and the private key. The public key is then sent to the application, and the application would store it on their servers, and then the private key would remain on the device. It will never leave it. So then at authentication and verification, when you log in, the service sends the challenge to your device, and then your device uses the private key to sign the challenge and then sends it back to the application, and then the application would verify with the public key, and then you basically get to use the service. So if the verification is successful, you get access to it. So as we can see, passkeys, they offer significant advantages in the realm of secure authentication, eliminating the need for traditional passwords, which are not secure. This method not only enhances security, but also simplifies the user experience. It really doesn't take you much than look at your phone or use the biometrics. However, even with the robustness of passwordless authentication, the dynamic nature of cyber threats requires a multifaceted approach to protecting your digital identities. This brings us to risk-based authentication. You may have heard the term behavioral authentication, which is a part of that. Risk-based authentication is a way more sophisticated approach that actually complements the security of passwordless authentication. Because while passwordless actually ensure that the credentials themselves are highly secure, risk-based authentication actually adds another layer, constantly checking for context and the behavior of the user, evaluating it to make sure that the proper risk assessment there is going to further strengthen the security of the authentication process. Unlike the traditional authentication methods that apply uniform approach to all users regardless of their behavior and their context, risk-based authentication is actually going to be incorporating that contextual data and the machine learning to evaluate that risk and then provide a tailored approach to enhance the further security while maintaining positive user experience. So to put it shortly, users who are logging in with good intentions, they will be let in easily, and those who are malicious will not be. So the factors that risk-based authentication is using are going to be identifying whether the login attempt is coming from a familiar IP address or not, similarly checking for the geolocation, making sure that it's familiar to the device as well, comparing the current login attempt to the normal user behavior and the time that they actually access the application. Analyzing the typing speed and the patterns that they use and see if it matches the typical behavior. Also identifying the device that is being used and also the browser configuration. Ensuring that the login attempt of the user, kind of similar to how user normally interacts with the device, with the mouse movements and touch patterns. And also, it will be incorporating data from third-party services about some known threats and attacks and suspicious activities to also further enhance the security. So this is how the system identifies malicious login attempts. And then based on the risk level that that's basically assessed by the system, it can take several actions. So what it can do is, first, it can expedite the login. So if there is a low-risk assessment, the login process will be expedited, allowing the user to get into the system without any problems. For medium-risk scenarios, risk-based authentication is actually going to use step-up authentication when it's going to request maybe the second factor to log in. And then if the risk is deemed high, then the system is going to block that login attempt outright, just to prevent potential unauthorized access. So basically, risk-based authentication, it eliminates the need for the uniform, kind of very stringent, secure system for all users, allowing resources to solely be focused on the threatening and higher risk scenarios. So overall, by integrating passkeys with risk-based authentication, organizations can achieve a way more comprehensive and adaptive security posture, really ensuring robust protection against the wider range of threats. All right, so actually that concludes our Cisco U session today. Just to wrap it up, what we have reviewed today was the ever-growing need for increased security measures against malicious actors, especially when it comes to protecting digital identities, which is still the primary attack vector for most cyber criminals. We have reviewed the basics of authentication security, and also we looked at some advanced authentication methods today, such as passwordless and risk-based authentication. So I hope it was helpful. I hope you learned something new today. Thank you all very much. Before you head out, though, I have an assignment from this group. Actually, I think there are 2 of these blue tickets hidden under the seats somewhere. So if you would like to stand up, take a look. There is a raffle, and we're going to win something. Oh, yeah, there's 1. There's 2. Yay. Awesome. Thank you all so much. Thank you for your attention. Thank you for coming to the session. Woo!
Good afternoon, everybody, and welcome to Understanding Meraki Licensing. So this is one of those things that we've gone through co-term, then we went per device, and now we're going to do subscription, right? So my name is Alan Gardner. I'm the CEO of Current Technologies Computer Learning Center, and also Triple CCIE. We wrote a lot of the Meraki coursework, and this is Alex.
Hi guys, I'm Alex. I've been working with Meraki since 2016. I've worked with schools, hospitals, education on rolling out Meraki and really getting to spend time with different companies and learning how they roll it out so that I can help you guys.
All right, so we don't have a lot of time, so we're going to move pretty quickly here. So the Cisco Webex app, right, you'll find that there's a space for this that you can join, and we'll answer questions, any questions after the class or course, right? So in this, we're going to talk about Meraki, right? We're going to talk about licensing overview. We're going to talk about co-term, per device, then subscription. We're also going to talk a little bit about EA licensing, and then we're going to talk a little bit about security licensing, right? You got Secure Connect, right? And you also got Umbrella that we can connect in the Meraki world as well. So, Alex, you're up.
Okay, guys, so here we're going to start with an overview of Meraki licenses. So with every device you have, guess what you guys also have to have? A license. Yeah, great, guys. So these licenses, you know, we like paying for licenses, right? But licenses with Meraki allow us to have software features that are continuously getting updated through the cloud. So as they go in and create new features and new things, instead of paying for an additional software key or this, that, and the other, your licensing also gives you those features. Now, what comes with those licenses that we pay for? So we have centralized management and network-wide visibility and control. Again, seamless firmware and security updates. So as Meraki comes out with new stuff, your devices can then use those new features. And then phone support and a lifetime warranty. Now, the lifetime warranty of the device, not our lifetimes. Now, different Meraki licensing types. So when we talk about licensing types, we talk about it in two categories. So we have the different licensing models, which we'll get to here in a minute. But then also, depending on what type of hardware you have, licensing is a little bit different. So for MR and MV devices, so the wireless devices and the cameras, so you have one license type per device. So when you go and purchase that license, whether it's for an MR57 or for an MR56, that MR license will cover either model. So if you guys are using, the MR50 or the MR56s and you guys switch to the 57s, that one license will cover both devices no matter which hardware device you guys have. Now, with MS, which are the switches, and our MX, so our firewall SD-WAN devices, it's a little bit different because these licenses tie to per device type. So for example, we have two MS355s here, so a 24-port model and a 48-port model. Now, if I have a license and I have a 24-port, and then I upgrade, I'm like, hey, I need the 48 ports per switch, and I go and get the 48 switch port model, I have to go and get that license for that specific device. So you have to make sure, especially with MX and MX, that you have the correct license per hardware.
But wait. What if we do subscription licenses where I can sell you a family of licenses? So now, if I go within the same family, small, medium, large, I don't got to go get a new license. And that's what I'll end up talking about, subscriptions.
Yes. So here we have MX. So for MX devices, there are 3 different tiers of licenses you can go with. Now, usually when we talk about enterprise licenses, it's usually the top one, right? In Meraki, it's the opposite. Your enterprise is your base license. The Advanced SD-WAN Plus is the top tier license. So here we can see each features that are included with different license types. So just make sure that the license you get for your MX has the features that you guys want. So again, enterprise at the basic, advanced security, which will have more of your security features such as AMP, IDS, IPS, content filtering. And then you have SD-WAN Plus, which also comes with the Thousand Eyes integration that came out last year, local breakouts, internet routing, and then also MI, Meraki Insight, is involved or is included with that as well. Now, MS, so Meraki switch. All of your switches, except for the MS390s, you have one license, and that is the enterprise licenses. Now, if you have MS390s, there is an advanced license that you can get, and so it includes adaptive policies, NetFlow v10, encrypted traffic analytics, and if you're using OSPF, you can use greater than 1,000 routes.
And if you're doing the 9300M, there's also an advanced license.
Yes. Also here, next we have MR. So, MR, there's really 2 different licenses. You have the enterprise and you have advanced. Now, if you already had the enterprise licenses with the basic features when MR came out with just their normal license, you had the upgrade license or the advanced, which then added umbrella capabilities when Meraki pulled in umbrella. Now, if your device didn't already have a license, you could then go and just purchase an advanced license. But if you already had MR devices out there that already had enterprise licenses, instead of going through and exchanging every single one of those enterprise licenses for an advanced, you could just get the upgrade license, add it to your enterprise, and it would act the same exact way as the advanced license. So again, the upgrade or the advanced license gives you umbrella capabilities with your MR devices. Now, MV, which are the Meraki cameras. So Meraki Vision, again, every device has to have a license. And again, with different license types, you have a few different time periods that you can purchase those licenses for. So for cameras, it's 1, 3, 5, or 7-year licenses that you can go and get for those devices. Now, 16 models, but only 1 license SKU. So I talked about this earlier. Any license you get for MV covers all of the cameras. Now, do know that there are some extra licenses that you can get to add features. So for example, Meraki cameras store all of the, but you can go in and do cloud licensing as well. So you'll go and pay that extra license, and it will keep that on the cloud for you as well if you want it on the cloud, and you'll pay for a license for that. There is also an extra license for analytics as well. Again, these are add-ons with extra features if you want them. The base license covers all the base features. Now, on all new, so anything that is not a Gen 1 MV device has a 5-year warranty, so Gen 2 up. Anything below, so if you have the Gen 1 cameras, I think it's a year, if I remember correctly. Fact check me on that one later. Now, with licensing models, we have 3 different models. So we have coterm, we have PDL, and then just came out recently, we have subscription. Now, if you're a brand new Meraki customer, everyone starts in coterm by default. So if you want to opt in on one of the other 2, either PDL or subscription, PDL, you have to call Meraki support to be able to use PDL licensing. Subscription, you'll go to your coterm license page, and from that page, you can go in and change your licensing model to subscription, which Alan will talk more about here in a few. So what is the difference between coterm, per device, subscription, and then we also now have FedRAMP. So last year, Meraki is now doing FedRAMP as well. And then we also have our EA agreements as well. So this is a chart that has all the different comparisons between the different licensing models. Also, just so you guys know, for those of you with cameras, these are going to be in the Cisco U session as well, so there will be a PDF with all of this on it. So here we can go in, again, just see the difference between coterm, PDL, subscription, FedRAMP. I just give you guys a second to look at this, and enterprise. I'm going to talk about a lot of this stuff as we go through this session. So we're going to start from where Meraki started with, which is coterm, and work our way down through the different licensing models. So co-termination licensing, what is it? How does it work? So basically, when Meraki started, they started with coterm licenses, where we take all of the licenses for all of our Meraki devices, and we put them in a nice little mixing pot. Now, depending on your different licenses, so how expensive that license is, what device that license is for, the length and time of that license, so like a 1-year license versus 7-year license, they will give you, so they're going to put all those licenses, all the dates and everything in a mixing pot, and you will get 1 expiration date. So all of your Meraki devices expire at 1 point in time. The advantage to this is if you have thousands of devices out there, I don't have thousands of expiration dates to keep track of. I just have 1 single date where, you know, if I don't pay for more licenses, everything stops working. So now, how do we go in and get that date? Because that's a little complicated, right? So instead of going in and purchasing a license for a specific serial number or device, again, you go and do it for a device type. Now, you will have a limit. So if I have 5,000 Meraki devices, I will have to have 5,000 licenses. So that number will need to match up in the dashboard, and the license info page shows you really simply where that lineup is and where you are in your number with licenses. Now, the date that they come up with that they give you for expiration, again, this is a weighted average of the licenses that you have purchased and that you have added into your dashboard organization. So they're going to go in and take an average of all those licenses, mix them up, and again, give you a single expiration date. Now, Alex, what if I wanted to go and, create a magical, little situation of, hey, I want to possibly go and add 3,000 more APs that have a 5-year license, but how is that going to affect the single expiration date I have now? Well, the answer to that question is we can go in. Oh, let me go one more and I'll come back to that. We have the licensing calculator. And so there's a link for this. Again, you guys can get to this link. It's not on the Meraki dashboard. And so this allows you to go in and basically be able to go in and put in the licenses you have and then the licenses that you want to have, and it will give you basically your expiration date for what your organization would be. So this helps with purchasing because, we have to plan for what licenses we're purchasing and putting in, right? So this allows you guys for, your financial team, for you guys to be able to go in and calculate this date before you just buy the purchase licenses, throw them in, and hope for the best date. So if you go in and click on this link, it will take you to this page. So this is the licensing calculator. And so I can go in. Here you can see these are the licenses that I already have in my org. And then I can go up and I can add, hey, let's just say we want to go make a purchase. So I want to get some 1-year licenses up here at the top for enterprise, and I want to do that for my MS-128s. We have some MS-350s, some MT devices, and other devices up here at the top. So if I go in and I say I want all these devices to have a 1-year license, I also want to go in and add a few licenses for some MS-355s, I'm then going to come down here to calculate license date, and it will take these licenses, it will mix them with the ones I already have, and then it's going to give me what that new expiration date would be as of today if I have all of those licenses added to my current organization. Now, let me go back. So when do my licenses activate? This is really important because depending on what licensing scheme or model you guys go with, this is a different answer. So with Coterm, the moment you purchase those licenses, they start turning and burning. So do not go and purchase your licenses until you're ready to roll out. Now, if something happens, you have a project, you purchase the licenses, and let's say something gets pushed, you can call Meraki support, and they can help you be able to push that date a little bit, but you do have to call support and talk to them, and it is on a per-case basis. So I make no promises, but I have seen them help a lot of companies in the past with this issue. Now, how do my licenses work? When I have licenses and then I buy new ones and then they all expire, right? All this is a lot. So I have licenses. I buy my original licenses, and however long that time is, my licenses expire. That time hits. Now, Meraki doesn't want to go in and immediately just shut off your org, be like, you have no license, you have no devices now, and take everything down. Right? So what they're going to do is they're going to give you what we call a 30-day grace period. So you have 30 days basically to go in and buy new licenses before all of your devices, again, because they all have one expiration date, all of them will stop working if you hit this 30-day period and you haven't renewed your licenses. Now, this is not 30 days of free Meraki, right? We would like 30 days of free Meraki, but what happens is when you purchase those new devices, those devices are going to eat up that 30 days of the grace period or however many of these days that you used. Now, again, if an emergency happens, you realize that someone didn't purchase the licenses and it has to go through several teams, and you know it's going to take longer than 30 days, again, call Meraki support. They can help you with this issue. Meraki support team is great. Talk to them, and they can help you work this out.
Now,
but 30 days is the standard, unless you're using subscription.
Now, wouldn't it be really nice if Meraki brought out a new licensing model where if it went beyond 30 days, you just lost management, but everything still works, right? Because that's a big deal is, what if those 30 days come and I haven't got a new license? Well, in subscription licensing, we're going to talk about, it just becomes unmanageable. It still functions. So it'll still work until you get your licenses.
Yes. Now, code term in the dashboard, so to go a little bit quicker for time purposes. So here we can see what the code term page looks like in Meraki. We can see license status. We can see that expiration date with what I currently have up here at the top. We can see for MX and MR and Systems Manager, if we're using them, what license tier we're using. And then I can see my license limit, which is how many licenses I have added to my organization. And then over here, we can see the current device type, so how many devices I currently have claimed and in a network in that organization. So it doesn't count against you until you put it in a network. When you put that device in a network, then it adds to this page and it counts. Now, here we can see licensing great, no issues. Warning, that means I am within the 30 days of my license expiration.
Or you've added more devices than you have licenses for.
Yes. Now, over device limit. So here we can go in, again, 2 reasons that we can be over the device limit or we can have license required, which is red. 1, I have more devices than I have licenses. And 2, I have gone past my 30 days. You will see this license required go red. So here we can see our license has expired. And then here we can see not only has your license expired, but we've gone past those 30 days of the grace period. So now you are also shut down with this little red banner here at the top. Also, anytime you log into the dashboard, if you are not compliant with licensing, Meraki will let you know. If you look at the top of your dashboard, you'll see a nice little license required in bright red that you cannot miss. Now, PDL. So the next licensing model is PDL. So basically, I could go in and get 1 license per device. Now, one thing I'll tell you is Meraki is encouraging you either to go to co-term or to subscription. So for that purpose, I'm not going to spend a lot of time here, but for those who want to use PDL, I'm going to go over it a bit, and if anyone has questions after, let me know. So PDL, again, allows us to go in and have individual licenses per device. So again, there were some advantages to this over co-term originally, which was, again, the ability to license devices individually, partial renewals, 90-day license activation window, APIs, and then instead of my whole organization shutting down, it was just the individual devices that were out of compliancy. Now, here we can go in and basically go in and claim licenses. So again, each license could have, or each device could have its own license. And we could also go and tie this to networks as well. This is what the inventory page, so there's a new licensing and inventory page which combine the inventory and your licensing into one single page on the dashboard. And we can see that here. So we're going in and claiming a license or claiming a device, works the same way. Here we can go in and see just the different tabs of the PDL page. So we have the overview tab. Oh, let me go back. The devices, licenses, expiration dates, networks, and then the changelog for any time I change something. Now, again, the new and upcoming is subscription, and I'm going to hand this over to Alan. Thank you, guys.
All right. So part of the problem with co-term was it's everything in my entire org goes at the same time. And what if I've got different divisions that I need to separate out, and I need that division to pay for their Meraki and this division to pay for their Meraki? Co-term wasn't very flexible in that. Now, per device was flexible, but it was hard to manage because now I'm tracking individual devices. I've got a customer with 30,000 devices. I don't want to track per device for 30,000 customers or 30,000 APs. So Cisco recently came out with a subscription model where now, right, basically, I'm going to buy a family. And so when I buy a switch, I can buy it small, medium, large. And as long as I stay within that same family, I can go from one to the other. I don't got to have an exact license for that model anymore. So over here we see ease of management, control over end, right? And with a subscription, I can go in and add licenses on the fly without having to do anything inside the dashboard, right? They'll automatically come in, right? So for customers, brand new customers, renewing customers with legacy, right, who have reached their full expiration, right, cloud licensing is where you should go, right? So I'm a little short on time here, so I'm going to skip ahead here. So claiming is done once during the life cycle of a subscription. So no longer do I need to go out and buy a new subscription and continuously keep claiming subscriptions. I can just basically cut a PO, add devices to a subscription, right, without having to do anything else, right? Now, right, network-based, so I can have a subscription bound to a network. So I can have one subscription bound to 100 networks, or I can have 5 different subscriptions bound to 5 different networks in the same org, right? So it gives me flexibility, right? So if I look at the MX, they come in families, right? So you see the Z series. So if I had a Z3 and I go out and buy a Z4 hardware, I don't got to go buy a new license. I can reuse that same subscription license from a Z3 to a Z4. On an MX, you see small, medium, large, and extra large. So if I have MX75 and I want to go to an 85 or a virtual machine MX, I don't got to go buy new licensing. I can just swap the licenses. So it provides a lot more flexibility when it comes to changing out hardware. Right? On the MS side, again, same thing. I can come out here and I can go with the large and I can go with a 350/48, a 355, or a 390. Right? And especially when we start seeing all these 9300s start coming down the pipe, right? 9300 IMS, right? That's going to be a huge bonus to be able to do that, right, in there. So again, I can do prorated mid-chirp changes. So if I want to add, 50 switches, I can cut a PO and add that to the subscription without going and getting a new subscription. And where that's really going to come into play, I think it's June 24th, EA is going to release for subscription licensing. So that's coming down the pipe here really shortly. Right? So the ability to come in and add licenses, upgrade licenses, extend licenses, right, within this subscription. So again, easy to manage. All I do is go in there, I claim a subscription once, and I'm done. Right? When you add devices to the subscription, they automatically show up in the dashboard. You don't got to do anything. Right? So now, subscription expires. This is brand new. Right? You can have automated enforcement actions will directly relate to the actions brought by to the customer out of compliance. So no longer will a customer's network stop working. Right? The management of the device, right, will stop working, but the device will continue to function even after the 30 days. That's something a lot of people have asked for a long time, right? So a customer subscription expires, subscription enforcement restrict management, device does not come down, right? Same way, product change overage, right? Only the device that's over stops working, not the rest of the org, right? With co-term, everything stops working. In subscription licensing, only the overages stop working. So also the ability within subscription is with a click of the button, I can go from essentials to advanced. Right? I don't got to reorder. I don't got to do anything. I can do that directly within the subscription. If I have advanced licenses, I click it, it'll deduct it directly from the subscription. Right? Renewals. Right? So releasing this week, I think, we now can set up auto renewals, right? And we can also do manual, right, renewals as well. So subscription licensing on the dashboard. So basically I'm going to come up here and I'm going to add a subscription in here, right? So I'm going to claim the subscription. Now there's one key difference here though. With subscription licensing, I can have 1,000 devices, right? I still got to go to the individual networks and assign a subscription to it. It's an automatic. So a lot of people get messed up. They apply the subscription and think, oh, that's going to cover all my networks and all my devices. It's not the case. You have to go in the Networks tab and then bind that network to the subscription. Because remember, we can do multiple subscriptions in the same org. We don't have to do just one. Again, I might have one department that pays for Meraki, right? And the subscription comes out of their licensing, and another department, totally different. And in the old days, that meant a different org. Today, we don't have to have a different org. I can take different subscriptions and apply them to different networks within the same org. Now, again, here's the network tab. You'll see the list of all the networks, and you click right over here. And again, now I can supply the subscription. And notice in this example here that I've got 2 different subscriptions applied here. Right. So if I want to bind it, I just go to the network, I click on it, I come over here to bind a subscription, boom, I'm done. That easy. Right? Now, one of the things you see here is when you come up here, you're going to see all the different devices up there. Right? And look at that MS100 small. Look at all the different switches that are covered by that license. So no longer am I constrained to that one SKU, I'm constrained to the family now, right? And so again, the more CPU, the more ports, right? That goes small, medium, large, extra large, right? Now, I know I got 3 minutes, so I want to talk really quickly about EAs. Again, the subscription licensing for EA comes out in, I think, 2 or 3 weeks from now. So right now it's co-term based. You will have the ability on EA to be able to do that within an EA. And some of the benefits around that is a single agreement to cover the purchase of licensing for all your different devices. And one of the big things is, what happens every August in Cisco world? Right? They raise prices, right? If I lock in an EA, guess what? I've locked in those prices for the entire term of that EA, right? So now I don't got to worry about, hey, do I budget properly for next August or the August after, right? So currently co-term, subscription coming, I think the 24th, 25th of June is when it's going to release, right? So whenever I have this, and one of the things you should see here is, look at my license limit. So when I have an EA, guess what you see? It's consumption-based. So I no longer got to worry about, do I have enough licenses? At some point, Cisco has an audit that comes back and said, hey, this is how many licenses I've used, and we'll true up those licenses in your EA agreement. Right? So one end date across all orgs, eliminate license claiming, right? Renewal considerations true forward, right? Fixed list prices for the term of the EA, right? So, a couple of things I want to talk about. I only got a minute, but one of the big things is we've been doing Umbrella for a while, right? So there's the license SKUs for that. What I really want to talk about is Secure Connect, right? We have Secure Access and Secure Connect. Secure Connect is the Meraki piece. This gives you not only the Umbrella access, but access within the Meraki console. So it's now easy to add VPN direct. It's now easy to add, all the different services over here. And we've got a Foundations package, and we've got a Complete package, right? And if we look here at the features, all the Umbrella features, but we also get the remote access. So zero trust is a big thing out there in the world, right? When you talk to people, everybody's about zero trust. Well, we can now do zero trust VPN directly out of Meraki, right? Cloud authenticated, directly tied in with Meraki authentication. That whole piece is there. Right? So, a couple things, evaluations, please do them, right? I got 30 seconds. So, continue your education. Right? Now, current technologies, we've written all the Meraki courses for a long time. So we have a 5-day full stack. We have MX, MS, MR. It includes the latest dashboards. It includes all the Catalyst stuff, so the Catalyst switches, Catalyst APs. So if you get a chance, right, feel free to come out and take a look at us, right? And the last thing is, I assume you guys are all Meraki people because you're in the Meraki session, right? Meraki has an insiders group called Meraki Insiders. This is a group that you can belong to that gives you access to like news events when it comes out. There's a special conference over here, so there's an insider booth. If you haven't been there, go over and take a look at it. So it gives you early access to some things and some other things, right? And I'm done. So thank you. Oh, wait.
One last thing, check under your chairs, because under 2 of your chairs you have this blue ticket. So for those who have this ticket, come over here, you get a free Cisco press book.
So thank you guys.
Awesome, thank
have
you
a great
guys so
conference.
much. If you have any questions, we're up here, feel more than free to come ask.
You're welcome.